And here we go. We have liftoff. Propulsion continues to be normal.
R68 chamber pressure looks good.
Probably not. Roger, planet.
Water towers fly! Yes!
Tango down to nominal.
Flight downside FD off. Bring in FD off. Off. It's orange!
45! Oh my god! Oh my god!
Decollage. What do you think? Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
If there's methane, it'd be igniting in the flare, correct?
Yikes. Keep red. Sure. We don't need any more of these.
Think here and see us. Alicia's here with me.
Hello,
How you doing?
everyone in the flesh. We are back together again
It's
at
true.
Kids Week at the Intrepid Museum. Nice to see you all again.
That's what's going on. Every year, Intrepid Museum does Kids Week, and it's a festival of sorts.
It is our big annual festival here.
let her
It's,
tell you.
it's during kids' winter break here for the schools, so the parents have their kids, they're looking for something fun to do with them, and so they bring them here to the Intrepid Museum. It's a week long. It's February 17th through the 24th. If you are local or want to be local for this week, come on by. We'd love to have you. The first 3 days are NASA and space themed, so we have lots of space stuff that we're going to be showing you
That's
today.
today. Like today's
That's
the first
today.
day, right?
Today's the first
It's the first
day. That's
day. There's
right.
an entire week after this.
That's right. So first 3 days are space. After that, we've got arts and culture. We're bringing in like the Blue Man Group and the Bazillion Bubble Show and Madame
It's like
Tussauds.
animals and stuff.
That's the last 3 days.
like a
Yes,
zoo and
we've
stuff.
got animals that come. Sometimes we have kangaroos and stuff, robotics, all sorts of stuff. So whatever
Robotic
you're
kangaroos?
into, not yet. But
Not yet. No
I
robotic
like that
kangaroos.
idea. Let's do that. Maybe I don't know.
I mean, they're
you know what?
droids,
Maybe there are
actually.
droids.
There are all
There's
sorts of droids.
Oh yeah, that's great. So anyway,
interrupting
come on
her.
by. No, it's fine. It's fine. Come on by. It's just something for everyone. It's kids of all ages, we like to say, and it's just really fun. It's great. You know, we're back in full force now. We've got the whole hangar here is filled with partners right now.
Yep.
And there's a lot of fun stuff. There's a lot of digital stuff these days. I'm noticing there's some more like VR out here and cool stuff. So yeah, we're gonna show you some of it today.
And so if you're wondering what's going on here, like why is this on the NSF channel, Intrepid Museum is where a lot of NSF's field streaming tech started. This is the 9th year that I've been working with Intrepid Museum.
Really?
It's the 9th year. 9 years.
9 years? 9 times?
years. In 2015, there was the Space and Science Festival,
Yeah,
and Sawyer, the pun master, if you know Sawyer, actually introduced me to the museum because he was an educator
You
that
used to
worked
work
here.
here. That's right.
And he set us up for the Space and Science Festival in the fall of 2015, and we brought a bunch of live stream gear out. We sat underneath the Shuttle Enterprise up at the Shuttle Pavilion. We talked with Mike Massimino. We played Kerbal Space Program with Mike Massimino, and that was our first stream we did here from Intrepid
I
Museum.
love that. That's wonderful.
So every year when there's stuff that we can do, like I'm not based in New York, but I love to be able to come up to New York and share what Intrepid
And
Museum
we
is
love
doing.
to have him. We love to bring him.
Yeah, you just love to share what the museum is doing because there's all this cool stuff, all the cool booths you'll be seeing as we walk around and talk to people. Astronaut discussions. Tomorrow we're going to be having an astronaut discussion.
That will be live streaming on these channels as
We're
well.
doing that as well.
Come
That's
back.
correct.
3 o'clock.
Nice. But that's the thing. Like, we love to come out here. We love to support what Intrepid Museum does. Y'all see it. Today we have the fundraiser going again. If you're on the NASA Spaceflight YouTube channel and you do that fundraiser, not doing super chats or anything like that today, but if you do the fundraiser, you're supporting Intrepid Museum's
Thank you very much.
ability to share things like this. Like if you buy admission to the museum for Kids Week, you can come and enjoy Kids Week.
Kids
with your
Week is
kids.
free with
Yeah.
admission.
It's not like a separate thing that you have to buy. You just at the museum.
No, it's just part of it. It's just part of your day-to-day activities here at the museum. You can see the submarine outside. You can see the airplanes all across the complex. You can see, of course, the beautiful Space Shuttle Enterprise. Hashtag best shuttle, guys. And of course the aircraft carrier itself, which is a historic landmark, the Intrepid. So it's included with free. And also, if you're interested in becoming a member at the Intrepid Museum, we are running a special Kids Week promo for 20% off this week alone.
Everybody's got membership programs.
Yeah, so do that. Come visit us all the time.
But for real, we have fun with this. This is where a lot of our experience with live streaming sort of came from. We love to come out here and share what the museum's doing, especially like the astronomy live things when COVID started to happen and the in-person events were really tough that couldn't be done. Really, still being able to share this stuff with folks that aren't able to make it to the museum. So this is a totally live environment. There are guests walking all over. You'll hear
There are
the
live
background.
children
Yeah,
all
there's
around
live
us.
children all around. You'll hear the background noise and all that sort of stuff. But we're just here to show you what Intrepid Museum has going on during Kids Week 2024.
That's right.
All right, where are we going first? I don't even think
Well, let's start on over here, shall we?
We're going this way.
Go.
All right,
This way.
literally, we're just going to look at
We're
some
gonna
stuff.
go this way.
Hey, go
Where
on.
are you going?
I
okay.
was letting you go first.
All right. So let's maybe start.
Aha, quick, go to a booth where nobody's
I know,
at.
right?
They're just on their phones.
Hi, guys.
Hi.
So, thank you all for being here. I'm Alicia. I'm the producer of public programs here at the museum, and
Oh, hey, I'm Das, John with NSF, whatever. So
we partner with NASA Space Flight, and we love to kind of do this walk around every year where we just talk to you guys and see what you want to talk to us about. Tell us about your booth. Tell us about all of the initiatives that your division is working on.
Yeah, so I'm from JPL. We do we're Earth Science communicators here.
you can just
I'm
have
gonna
that.
hold this. We're Earth Science communicators. So today we're talking about ocean and water. We have a gigaton ice model over here that shows you how big a gigaton of ice is with a Empire State Building for scale in there. It's 1 kilometer on each side, so 1 kilometer by 1 kilometer by 1 kilometer. Every ice cube in these boxes is 1 gigaton. This is how much ice is melting from Greenland, Antarctica, and Alaska per year. And so we have a lot of missions that study that. One of them is called GRACE. It's a pair of twin satellites that chase each other across the planet, and all they do is they measure how far one gets from the other based on the mass that they're flying over. In doing that, they make a map of gravity every month, and as we compare those maps from month to month, you get an idea of the mass that's moving. And the only mass that moves from month to month is water. So you can see groundwater reservoirs being used up, you can see rainfall in the Amazon gets heavier in the spring, you can see ice melting, and all sorts of other cool data that you wouldn't be able to see otherwise from space.
Why do they waggle back and forth? Like that's them measuring just the distance to each other?
Yeah, so they don't measure anything on the ground. They only measure the distance from one to the other. And they move apart depending on the amount of gravity. So as one flies over something with more mass, like a mountain, it speeds up. And the one behind it is like, oh, you got further away from me. As it flies over something with less mass, like the ocean, it slows down and it gets closer. It's like, oh, you got closer to me. And so they just do that. They just go back and forth all day, measuring the distance from one to the other, and then they make their gravity maps.
So it's literally just like little teeny tiny changes. I don't know, teeny tiny. Is it teeny tiny?
So they fly 120 miles apart,
Right.
And they can sense changes in distance from one to the other the width of a human hair, 1 nanometer.
What do they use? Like a radio signal?
Like a
or
laser,
They
yeah.
use a laser?
Yeah.
No kidding. So they're just using a laser
Yeah.
rangefinder, I
Right.
guess.
So they don't measure anything on the planet. They only measure each other, and they get all that data from that.
No kidding.
Yeah, it's one of my favorite missions.
Is that like we're mapping the gravity changes, or are we trying
Yes.
to map, I guess, the fixed gravity or the changing gravity?
The
'Cause you talked
changing.
about water and mountains.
So you make a map 1 month, and
Yeah.
then next month you make another map, and you compare the two, and the change shows you the movement of water over that month.
Nice.
Yeah. So
what do we use that for? Like,
well, all sorts of things. You can measure droughts, like the draining groundwater reservoirs in California.
Yeah.
You can measure ice melt off of Greenland and Antarctica, especially things that are like under the ocean and you wouldn't normally be able to see. You can also measure rainfall. The Amazon gets heavier when it rains in the spring. Yeah, so all sorts of things. Grace went for about 15 years. Now we've launched Grace Follow-On. It's essentially the same mission, but again, so we can continue the longer record of data. And then we're now working on Grace C, which is Grace Continuation, hoping to do more science.
are they different satellites, or are they the same satellites that have been running and you're continuing them from like a mission perspective?
They're different satellites.
Different satellites.
Yeah. They're kind of like cars, right? Over time they break down, but there's no mechanic in
They're
space.
in orbit. You can't go visit them or change their
Right.
oil or whatever.
Exactly. So we built new ones, and the new ones have the like really good laser on them, so even higher quality data.
Like a cooler laser than the old ones?
I think the old ones were radar.
Ah, okay.
So the new one has both, just in case the laser didn't work.
Yeah.
Right, we were testing that out. So
Nice. How do they stay pointed at each other? like the lasers have to be it's not like a big flashlight wide beam. They have to be like pointing right at each other.
Well, they orbit. They're both the exact same weight. Like very careful to make sure that they're the exact same, and they just fly in orbit one after the other.
And they just they have the reaction wheels or thrusters or something that keeps the lasers pointed, or is it like on a little turret or something?
That's a good question. I'm not sure.
Okay.
I think it probably has a big enough plate that. Yeah, I'm not sure. It's a good question.
Good. I like questions. Good deal. All right. So this is Grace. Is this your? Do we have more satellites to talk about?
We also have Sentinel-6. Okay. Sentinel-6 is measuring sea level height. So Sentinel-6 is part of the super long history of altimeters. It started with OSTM, and then we had Jason 1, Jason 2, Jason 3. This is Jason 6, or Jason CS, which is continuity of service, and Sentinel-6. So this is measuring sea level surface height. And in measuring the sea level surface height, you're also measuring the temperature of the water, because as water warms up, it expands, and as water gets cooler, it decreases. So we can measure the temperature of the surface of the water, and using that, we can measure things like El Nino. We can see El Nino coming because it's a bulge of warm water moving across the ocean from Asia to North America. So all sorts of really cool ocean applications there.
Excellent. And hey, folks, if you're watching at home and you have questions, I've got my phone out. Like I'm literally watching the stream on my phone. So if you have maybe I should mute it. If you have a question for us, type it into chat, tag us at NASA Spaceflight. It's probably the fastest way for me to get it here. And I can ask some of your questions to our fantastic folks from NASA JPL.
Yeah.
All right. I was supposed to do that at the beginning so that they could ask questions and then I could get questions and then I could ask you. But
well,
y'all
you can
should
always
know
swing
how
back
this
around.
works. Yeah, exactly. All right. So
can they see on their screen? Like, so there's a QR code here. If you want, you put it up and they can actually hide it on their screen.
I mean, hey,
so
point the.
Basically, NASA has some new software that lets you look interactively at maps. Oh, sorry.
Yeah,
NASA has a software that basically will let you look at maps. They have asteroid mapping. They have Earth, solar system. So it's kind of fun because you can look on your iPhone. You can look on a computer screen. Nice. It'll give you access to some data, and you can like zoom in and rotate and things like that. So it's fun.
Yeah, if you're watching, you've seen us use that before. It's NASA Eyes. Yes. So you can either get to the QR code or just go to eyes.nasa.gov. One of the mods can put the link in chat or something like that for us, so y'all can click on it. But that is an app, or it's a website. I think
it's a
both.
website now. It's both.
Now.
Yeah. You can download the app, or you can use it on the web.
Yep.
And now it works essentially just straight up in the website. No downloads necessary.
Good deal. And it has like different missions and stuff in it. Like you can click on, I'm going to say like Psyche or something like that, and it'll zoom over and show you where Psyche is right now.
Yeah. So with Eyes on Earth, you can see all of the missions in orbit, and you can also see data sets from them, and you can see size comparisons with a school bus or a scientist. So you can see how big our missions are. We have things that range from very small, like CubeSats, to the ISS, which is gigantic.
Nice. And that's just all in NASA Eyes.
Yep.
It's NASA Eyes, right? Like that's the right thing to call it?
Yeah.
Okay, cool.
Yeah. So we do Eyes on Earth, right? Because we're Earthlings.
Sure.
But yeah, the whole like suite of them is NASA Eyes.
Ah, gotcha.
Yeah.
All right. So let's see if any questions came in.
Yeah, sure.
While this was happening, we stall for a second because I'm reading your questions. Let's see here. Rainfall in the Amazon, does it mean satellites are... Oh, this is a good question. You mentioned ice in the Antarctic and Amazon rainfall. What sort of orbits are the satellites in so that they can detect gravity over different parts of the Earth?
So they're in a polar orbit. It's a really good question. We have different kinds of orbits. Like the International Space Station is on an equatorial orbit. It goes around the width of the Earth.
Yep.
Grace and most of our Earth measuring missions are on polar orbits. So they go, north south, and they see about 16 or somewhere between 16 and 19 orbits a day.
Yep.
And so they get it takes them essentially a whole map to get the full picture of the Earth, and so that's why they're month-to-month maps instead of on a more granular scale.
Makes sense. It's not like a geosynchronous satellite that stays in one place. Like we use that for communications or looking down at one specific spot of the Earth. The way this works, I need like a globe, right? I don't have a globe. Here, here we go. This is the Earth. All right. Assume this is the Earth in 3D. It's now a 3D Earth. Oh, there you go. So if you have like a 3D Earth, and you have a satellite that's just going around the equator like this, then all that satellite can really see is stuff on the equator. But if you have a satellite that's in a polar orbit that's going around the Earth like this, then it orbits and the Earth rotates. And so as the Earth rotates and the satellite orbits, it gets to fly over different parts of the Earth because the Earth rotates underneath it and it's going over the whole thing. So you have a satellite in a polar orbit, and that lets the satellite get coverage over the entire planet.
Yeah, exactly.
Nice. A little bit less frequency because it's not always like...
Right, and especially because this doesn't have
year.
like a long, this doesn't have a big data swath. They're just measuring the direct track they're flying
Yep, just
over.
like right underneath it.
Yeah.
And as it turns, it sees a different part right underneath
so
it.
like the little slices, and they build up over a month.
Yeah, and that's why it takes a month, because at one day it'll be looking over this part, and it orbits and orbits and orbits, and then the Earth rotates, and another day or another week it's looking over a different part, looking over... Does this make any sense, or am I making a fool of myself? I'm going to read chat.
No, you explained it really well.
Yeah, it's a little bit of just like you see 3D helps. But the other thing is like when you think about it, like I think the other side, the science part of it, is that if you really think about how you capture that data, because when you get the swaths, right, the science math of it is that depending on where it is, you have to actually adjust for the fact that it's slightly different, slightly off, right? So as that satellite's moving across, you also need to then, basically change the what you're collecting.
Yep.
It lines up with the previous measurements as well.
Because it's not like a super clean, because the Earth is still rotating.
Yeah, but it's also moving across, right? So then it can capture part of what was captured previously as it's moving forward.
Do they overlap a little bit?
Yep. And then that's why you have to basically adjust it so that you can make sure that when you do the map, it's actually accurate. They capture everything the right.
That's most missions, not Grace.
No.
Grace doesn't have that issue because it's not scanning the
Because
ground.
it's not scanning, it just talks to each other.
Yes.
Gotcha. So does everybody understand that, right? Like, it comes down to, like, when you're designing the satellite in the first place, you choose sensors that have like a field of view or something, and that's how big the swath is, and then how far away from the Earth, like if you put it down here, you just see a little thing, the further out it is, the more that swath sort of covers, like the field of view covers, and then how quickly it's orbiting, like the altitude of the orbit that it's in, right, changes exactly what you're going to get, and you have to think of all that all the way back when you're designing the satellite. You just toss it up there and like, all right, let's see what it sees.
Yeah, each mission is often the project manager's whole career. They spend 10 years before it ever launches.
Nice. If you think about the satellites we launched, like 20, 30 years ago, like, so now you can do it in a month, right? But back then it was like, I think at least 2 years to cover the entire planet, like where you sent it out to space, so it took forever to do it. So it's actually pretty good when you think about it.
Well, Grace has been up for a long time, so we've had the good Grace data for a long time.
Nice. All right, well here, there's y'all all are on the stream. So I should probably actually pause that because I don't need to use that data. Let me see if there's any more questions here in chat. Kids Week. Well, it's called Kids Week, but we try to explain stuff that everybody can enjoy. You don't have to be a kid to learn from Kids Week.
Everyone's got a little kid in them.
There you go, kid at heart.
But when you said with the Grace data, right? So was it always one month to be able to collect all of the data?
Yes, it's always been months ago.
Nice.
The thing about NASA data, there's so much of it that everyone just knows one. Everyone kind of learns along the way.
It makes sense. Let's see here. I'm going to scroll through here. Caitlin, thank you so much. Like, everybody can learn from this. You don't have to be a kid to learn from this. And maybe I'm talking so fast right now because I'm excited about stuff like this. It might be hard for kids to keep up with me. But anyways, everybody can learn from this. Let me scroll through. It's a 3D Earth. It's not a flat Earth, all right? It's a 3D Earth. So I can't really make an oblate spheroid from that, but whatever. Let's see here. Oh, do you use gravity anomaly data to track magma reservoirs?
Ooh.
I don't know.
That's a good question.
Yeah.
Most of the mass that we're looking at is water.
Is the water.
But magma reservoirs moving would affect that. So, yeah.
I know, like, some parts of the Earth have sort of lumpy gravity where it's denser underneath the crust or whatever, then it's lighter underneath the crust.
Yeah.
Like,
and because you're measuring change over time, all of that is not a factor because the gravity, whatever the dense part of the crust, it'll always be that dense.
Yeah.
And so the only mass that's changing is water.
Is the water. Nice. All right. I'm going to keep scrolling through here. So, I'm getting flattered comments. Good grief. Usually I have. People are already looking at NASA Eyes. Like, for real, you can click on NASA Eyes and open up another window and look at all the cool science data they have there. And y'all like Eyes on Earth, right?
Yes.
Yeah, there's lots of different NASA Eyes, but now you should be clicking on Eyes on Earth.
Which you can find if you go to climate.nasa.gov. There's a little spinning globe at the top. If you click on that, it'll take you straight to Eyes on Earth.
Nice. Let's see here. It's just like super awkward. Like it's like super low profile. Any other questions, chat? If you're just joining, we're at Intrepid Museum. It's Kids Week, talking to folks from NASA JPL right now. I think we're good.
Awesome.
Yes.
Thanks
Earth
for
is not a
stopping
cylinder.
by.
I messed up because I held up. Earth is a cylinder. Yes, it's a
Earth
conspiracy.
is a cylinder now.
God.
Well,
Earth
thanks-
is a QR code.
Well, thanks for stopping by.
Yeah, thank y'all so much.
Thank you.
We appreciate it.
Amazing.
All right.
All right, well, let's head on over here.
We did the super fast and loose. Thanks for being
Thank you, guys. All right, we're going to head on over here and talk to more JPL people. Sarah. Hello. This is Sarah Marcotte. I'm sorry, I'm like putting you on the spot here. So Sarah is also with NASA JPL, and she is amazing. She has helped us to coordinate and wrangle a lot of these NASA partners this particular year for Kids Week. So we love her very much. So this is a stream here. Oh yeah, this is a stream that we do for our viewers and for viewers on NASA Spaceflight, and we just like to show them what's going on during Space Days at Kids Week, and we love particularly to highlight all of the cool work that the NASA divisions are doing. So I can just hand this over to you. Would you mind talking a bit about some of your major highlights and things?
Love it. Okay, well, thanks so much. Look at this little puffy thing. My name is Sarah. We're here from NASA's Jet Propulsion Laboratory. We have missions representing some of our spacecraft that observe the Earth. We have missions called Sunrise that are going to be launching and exploring the Sun, in orbit around the Sun. And then we are talking about our Mars rovers and our missions around planet Mars. So I've got a Mars globe here. I have a full-scale model of Perseverance rover's wheel. And then I've got a little mini Perseverance rover here. I also have things for people to touch and feel, like we have rocks and minerals from Earth, but we know that these are found on Mars. And we have cool things like thermal blanketing, so that helps keep spacecraft from getting too cold on Mars or on their way to Mars. And then look at this crazy thing. This is a 3D printed model of the end of the Perseverance rover's, the end of its arm with its science instruments. So we can do X-ray lithography and learn about minerals and rocks on Mars. We can use the spectroscopy in this instrument called Sherlock, which can take close-up pictures and learn about organics in rocks on Mars. And then this open area of this particular model represents where our rock drill is, where Perseverance can take core samples and hopefully we can bring those samples back to Earth. Then I do have a little robotic rover, which I have right over here, if you're able to come over, named Rovi. So I've got this little rover that I've been driving around periodically. And we'll just say hello, Rovi. Just have to turn it on. So it looks kind of fun. So I've been driving around telling people about how we operate rovers on Mars and showing them Rovi. Now also, people can take a selfie on the Sun. So we have this situation where you can draw a picture of the Sun and maybe you want to take a selfie in front of our beautiful home star. And then you can learn about our NASA missions that are observing the Earth. You can learn a little bit about global climate change. You can learn a little bit about the global ice loss that's happening, and in NASA missions that are studying our Earth and our Earth's moon.
And we've got someone coming in tomorrow, Joe Lazio, right?
Yes, Joe Lazio from...
He's a heliophysicist.
He is. He's a heliophysicist, and he is going to talk about the great eclipse that's going to be coming up in April. So he's on the Sunrise mission.
In case you haven't heard about it.
Yeah.
Big one.
By the way, there's going to be a total eclipse going across many portions of the United States.
And we will be streaming it on
Joe
NSF2.
Lazio will be telling you about, it says something like, Coming Soon, The Disappearance of the Sun, which is a good title, I think.
That's a little scary,
yeah,
I guess.
Exactly.
It's accurate.
Right. So, we love coming out here to meet the people of New York and the tri-state area and all the space enthusiasts that have come. And, of course, the crowds have been so friendly and fun, and kids of all ages and humans of all ages, and then, some people from other planets, too, we've been noticing.
And galaxies far, far away.
Galaxies
exactly.
far away. Nice.
Yep.
TM.
Nice.
Yeah.
Who's this?
This is Rovi, and I just have the controller sitting over here. So let me just go over here, try not to...
Is it like hiding for a reason right now? Should we not look at it? Or
No, it's not recharging. It's just I happened to be gabbing over there, and I just didn't have it on.
You parked it out of
I did. I
the
sort of
way,
just,
I think.
parked it over here.
Is that PlayStation controller?
It is an Arduino controller.
Arduino controller.
Arduino controller.
Gotcha.
Actually, let me just, this is a little hard for me to do with one hand. There we go. Oopsie, go the other direction. So we've got Roby. I've been basically chasing kids around with this. You know, Roby comes out and we can talk about how we command rovers on Mars, how rovers have 6-wheel drive, how they're designed to run over rocks of all sizes, and maybe what it's like to drive a rover on Mars. So sorry, I can't do this with 2 hands. I'm struggling a little bit.
Sorry, I saw it sitting down there. I was interested in it.
I'm
so
glad
I was like,
because
what's
I
that?
love people getting to know little Roby. It's just, I am not good at multitasking.
So it looks like it's got some 3D printed parts on it.
It sure does.
Yeah.
And it also, has carbon fiber and things like that. But we definitely have a lot of commercial off-the-shelf things. For example, this is an Arduino controller, and it uses an Arduino board and a Raspberry Pi board. Gotcha. So it's got stuff that people could actually reproduce this rover, without too much trouble.
Nice.
The carbon fiber might be a little cost prohibitive.
You can buy that online. I mean,
Right.
we just shipped. We were making a telescope, and we bought a bunch of those for the
good.
body of the
Okay.
telescope. So,
Love it.
yeah. So, is this a similar design to the actual Mars rovers from a suspension perspective?
It is. We built this after Curiosity landed.
Yeah.
And we were so excited to be able to tell the world about Curiosity. So we actually asked a bunch of engineers. I have to reboot her. Because I did something strange.
Turn it off, turn it on again.
Yeah, exactly. Turn it off and on, just like any electronics. So we actually commissioned a young group of engineers to to pretend that this was actually going to go to Mars.
Yep.
And so we gave them all the requirements for a Mars mission and said, can you build a rover, and it's got to come out to events, it's got to be light, it's got to have 6-wheel drive, it's got to have a rocker bogie system like the typical Mars rovers.
Is that what it is called, a rocker bogie system?
This is called a rocker bogie. So here, this pair of wheels is called a bogie.
Yeah, there's a hinge there.
Yep. And then this is called the rocker, and they are connected by this differential, and that actually helps the rovers on Mars stay stable so that they don't run over, tip over on Mars.
Is that an active thing where
It
this
is.
point is controlled actively?
It's passive in that it moves with whatever rocks the rover is driving over. So
Right.
there's no sort of actuator in here.
That turns
just
that.
a passive. Yeah. So
Okay.
the actuators are in all the wheels.
So it's just balanced or something in there because it's a single point of contact. How does the body stay?
Yep, the whole idea is that it's kind of a system that reacts to the terrain it's on,
Gotcha.
and reacts to the other set of wheels to keep all the wheels pressed down.
Not high centering or having one side way off the ground so you don't have any traction and the other side tries to dig in.
There we go.
Nice.
I know.
Now y'all see why I come to these events.
We gotta do this by camera.
You gotta like the underbody LED glow here.
I have to change my controller batteries.
Yeah. Should we bring it back
Yeah.
here out of the way?
Yeah, we'll change our controller batteries.
Stand in front of it like this because we're at Kids Week.
Yeah, because the batteries last really long in this thing, but my controller batteries don't last quite as long. So it stopped listening to me, and that's usually my controller, my Arduino controller. So something that people can buy off the shelf, Arduino and Raspberry Pi. So the whole idea was, you can build this too.
Yeah, I want one. My wife doesn't want me to have one, but
you
I
got
want one. It's where would I put it? It ends up in the living room. All right.
This is small enough that you can fit this in a New York living room.
Exactly. See, there's plenty of room. I have a garage. It can easily fit this.
There we go.
I mean, so should we move this back out of the way? Because I want to talk about the wheel. Let's put away our toys, I guess is the right thing to put it. I like how it's got the carry handle on top of it, right? There we go.
Yeah, let's put that over there. We can talk about the wheel.
But
It actually gets stretched out. So the universe itself is expanding.
Oh, she's just going to grab the wheel for us. We're trying to stay away from the speakers because the speakers are really loud. This is to scale?
This is a full-scale model of Perseverance's wheel.
No kidding.
Yeah, so the flight wheel would be made of anodized aluminum.
Right.
With titanium flexures or spokes.
Are these the flexures?
They're the flexures, yeah. So, and then the motor would go inside the rover.
Okay.
So we got the design files from the engineers and said, hey, can you mind if we make some models? And they said, go for it.
No kidding.
It's just kind of fun to have a tire that people can see for scale to get a sense of how big the rovers are.
A lot of people don't understand how big the Mars rovers are. Like you look at it and you think it's like a little RC car driving around on Mars, like this sort of size. But the actual Mars rovers are the size of a small car, like a real car you can ride.
Yeah, they're kind of the size of a Mini Cooper.
So
the first rover we sent to Mars was about that size,
the
Sojourner.
Yeah. Sojourner.
And then they just kept getting bigger.
They just kept
supersized. So Curiosity and Perseverance are about the same.
Yeah.
Size, approximately. Perseverance is about 3,200 pounds.
3,200 pounds.
On Earth, yep.
My Toyota Camry weighs about 3,600 pounds, so about its weight, almost the weight of my Camry.
Yeah. You got to carry a lot of, science tools and computers and make these things very robust so that you can last for years and years on Mars.
Yeah, that's the part where JPL is like, all right, we're going to have a rover that operates for 6 months, and then 9 years later, it's still driving around and
We're still
rocks.
Going. So true.
But people just don't realize that the rovers are this big. Like we see pictures of people standing next to the rovers. You get a scale of a wheel like this, and you realize these are big things that we've sent to Mars.
You do need to get a sense of scale. And actually, 2 years ago, we had a full-scale Perseverance rover here at the Intrepid.
No kidding.
Yeah, 2 years ago, and it was on its first anniversary, its first landiversary on Mars.
Yeah.
We had a model here for about 6 months. Yeah.
Nice.
It hung out next to its friend, the shuttle.
The shuttle,
yes.
Nice. So people have been asking questions. I have to look at my phone while I get some questions from chat here.
Oh, love it.
Don't ask what these are for. This is like the next thing I think Alicia said.
Love it.
But let's see if we have any questions from folks back home. Is that thing heavy? Like you don't have to hold
not
it?
bad. No.
Okay, cool. Let me hop in and see if I can get some questions from the chat. Where's my question queue? There we go. All right, thanks for doing such cool events. Thanks to NASA folks for coming out to Kids Week.
Yay,
Everybody's just
so
saying
much
thanks
fun.
so far. Somebody saw a shuttle somewhere, apparently. All right. The layout of the wheels. Oh, the inside. Somebody was looking at the inside of the wheel. Hey, why is it such a weird shape inside? Like it's got a big curve, and then it's not even attached right there. It like goes like see back there.
Oh, okay.
Why is that so weird?
Oh, isn't that interesting? Okay, so that is because this is a springy suspension. This rover and the previous rover landed on their wheels. So this is like a spring to absorb the impact of landing. You're only going about 2 miles an hour when you land on Mars. However, it's a big, heavy rover.
Right.
So these titanium and aluminum wheels actually absorb the impact of landing.
No kidding.
And these flexures, this design, was designed by a mountain bike manufacturer in Tennessee.
No kidding.
Yes, one of the rover wheel designers years ago was an avid mountain biker, and he actually went to this particular company and said, how would you design something that could, sort of land on Mars and absorb and spring back and be light and be springy? Nice. And they said, well, what about titanium? And they came up with this cool shape. I know, I'm kind of crazy about the shape of these. I think it's really pretty.
Well, I mean, think about it. Like, your car tire probably has air in it, right?
Right.
And you don't want a tire on Mars to have air in it because pressure changes and there's not very much pressure. And then how are you going to air it up?
Yeah,
right?
and rubber is going to freeze and crack.
Exactly.
So that's why we use metal, which can handle the 100-degree swings on Mars.
No kidding.
Yeah, so,
but your car tire that has air in it is rubber, and it sort of springs a little bit, but you can't have a rubber car tire with air in it on Mars.
It doesn't work on Mars.
So you design something like this in the titanium structure, and the way that shape is helps the wheel absorb impact.
It does, yeah. And then, of course, it helps along the way of driving over all the rough terrain that we have
things
to
out.
drive
It's like
over.
part of the suspension is built right into the wheel because it's not a bouncy air tire.
Definitely not bouncy, filled with air.
Nice. No kidding. Let me see if I can get one more question here.
Love it.
And again, we're just like I read the questions off my phone.
Yeah.
Missions, ESJPL is always under-promising and over-delivering.
Like it.
I think that's not a bad thing to have, right?
Maybe that should be our motto.
That's your slogan. That's put it on a bumper sticker.
It's like 6 months. Yeah, right. 3 flights. Yeah, right. We'll try to find
Keeps on going.
Yeah. Ingenuity team. Let's see. Nice how it pivots to keep traction with all the things. That's what we were talking about, the rocker bogie system, right?
Yes. Mm-hmm.
And it's just, it doesn't have like pistons or anything like that. It just reacts to the terrain.
Exactly,
right?
exactly. It's kind of a passive system. There's
Yeah.
no actuation in that. It's really reacting to the Mars environment.
Yep. So it just drives over the terrain and it sort of matches the terrain. It doesn't have
Exactly.
to have a laser scanner and it's like, that rock is this far away, raise this way. Like, it doesn't do
Right.
that.
Yeah.
It just uses physics.
It just uses plain old physics. However, the rovers are direct controlled from Earth,
Yep.
but we have put in a lot of autonomous driving capacities too. So now the rover can actually be given a target to head for, and then it has to steer around obstacles all by itself. So kind of a self-driving scenario. So it's exciting that the rover can use its cameras and find a safe path through the rocks.
Nice. So think about that, right? Like the distance between Earth and Mars means it takes a while for commands to get there.
Yeah.
And if you're sitting at JPL in the center of the universe, that's what they have written on the floor.
Oh, you've been. You've
I've
seen
been,
our
yes.
little...
We've done live streams from there, too.
Oh, great. Did you know there have been about 65 marriage proposals on that little
From the
thing
center of the
that
universe.
says 65? I mean, that's a lot of couples very happy on Valentine's Day.
We're not kidding. Like on the floor of the
Yeah.
JPL sort of mission control area, it says the center of the universe.
Yeah.
But if you're there and you're sending commands to Mars, it may take 7 minutes. If Mars is on the same side of the sun, it may take 14 or 15 minutes. What's
Yep.
the highest? Is it 14, 15,
I think 20 or 22 minutes.
20, 22
Yeah.
minutes if it's on the other side of the sun,
Right.
right? So you're not sitting there with a controller like, all right, drive. You
Right.
tell it, we want you to drive forward 2 meters or whatever. I don't know if that's a normal distance.
Then you typically send that command to an orbiter, and
Yeah.
then when the orbiter passes over the rover, it gives it a whole to-do list. And so it has to do a whole list of stuff, the honey-do list.
Yeah, the
And
honey-do list.
it gets the whole list of things, and it carries out all those commands.
Yeah.
And then, just like I might consider, it takes a nap. So it goes to sleep,
Yep.
and sends its data back, but it then goes to sleep. And then wakes up again, and there's probably another list waiting for it.
Nice.
Oh, can't catch
Never
a break.
ends. JPL never gives me a day off. Like,
Can't catch a break. It's got to keep working. But this rover, Perseverance in particular, has been able to go farther and faster because of this autonomous capability and because of all the things that the rover drivers have learned
Yeah.
after 5 rovers on Mars, because this is the 5th. So, you don't just operate the rovers and then kind of leave them. You use all the stuff that you've learned to make the next ones better.
Yep.
And the faster your rover can drive, the more science you can do. So they're happy that they can cover more territory and collect more rock samples.
nice. So, think about that. If the rover's driving and it comes to a rock and it has to stop and say, hey, mission control, I found a rock, what do I have to do? And then the commands come over, sends it to the orbiter, sends it back to mission control. Mission control says, drive around the rock, sends it back to the orbiter, sends it back down. Okay, think about how slow the progress would be.
Right.
And if the rover is smart enough to use its cameras and say, hey, that's a rock.
Yeah.
Well, mission control wanted me to go 10 meters in this direction. There's a rock in the way. I'm going to drive around it and then keep going in that direction.
Going. And we even have now artificial intelligence, and the rover can choose its own rock targets to study.
kidding.
So it's a system called Aegis, and the rover, when they turn that on, the rover can survey rocks in its area, and if they meet certain criteria, it might use its navigation cameras to take pictures of the rocks,
Yeah.
and it might use its our supercam to zap into the rock and make a little puff of plasma, and the spectrometer can read what that rock is made of.
Yeah.
And then people send it back to Earth, and then people on Earth might say, "Ooh, that's a good one." Go closer and take a sample or use the close-up spectrometers on that rock.
No
So
kidding.
the rover can actually decide which ones it wants to zap or to investigate further.
I wonder what it uses to decide that. Is it like that rock has a good shape or color or
It's a whole list of
Rockiness.
criteria. Yeah, it's a whole list of criteria of how hard it is, how large it is, what it's in relation to. There's a
Yeah.
lot of things that geologists see in these pictures.
Yeah.
And they've taught the rover to look for those same things. Whoopsie! Oh, I almost tripped. I almost tripped a little person.
Okay, it's all good. It's an active museum environment here.
It is. It is. There are lots of little people all over the place.
Yep.
Lots of
That's-
under the knee type of visitors.
You have to make sure your awareness is you
So
have to
true.
scan the ground in front of you, much like the Mars rover does.
Yeah.
You like that?
Yeah. And that's what's so fun about this little rover, because it's about their size. So they see a rover approaching them that is looking them right in the eye. The little 2-year-olds.
Nice.
So,
like, imagine if the rover was here and had to use artificial intelligence to work its own terrain pathfinding around Kids Week.
Exactly. That would be challenging, because think of all the uncertainties in the trajectories of these little people.
And plus here, all the rocks, I mean the kids, they move around on you unexpectedly.
They do. You know, luckily on Mars,
to stay where they are
they'll
on
stay
Mars.
put. Yeah.
All right. A ton of people saying thank you so much for being out here. We'll let you get back to showing the kids
and
the
thank
rovers
you
and
so
stuff
much
like
for
that.
tuning in. Like, thank everyone for that. You want to go talk to Sunrise people or Earth people?
I was handed these.
Oh, good.
This is an
Love it.
thing.
Sure, want to check out the rocks?
Sure.
Sure.
Talk about the rocks.
2040 probably. And so the goal of the Habitable Worlds Observatory is to observe.
So these are, and not Mars rocks, but these are Earth rocks and minerals that we know are found in Jezero Crater, where the Perseverance rover is cruising around. So we like to put together this little kit to show people that Earth and Mars are made of all the same stuff. So there are some things that we have definitely seen in Jezero Crater, like this conglomerate. We've seen this in Gale Crater as well. We know that there was a flowing stream. Look at that little rounded cobble. That little rock was rounded by the actions of water. So we know there was a flowing stream at some point. And then we also have seen mineral veins in some of our rock types. This is called gypsum. And we've seen veins of this kind of mineral in some of our rocks. And the reason why Mars is red is because of hematite, which is like an iron-based ore, and it's actually rusting on Mars, and that's what gives Mars its reddish color. So we have hematite for people to feel. And some of my favorite is mudstone. This is a smooth, shiny, very light rock. This definitely forms in lake environments, and you would find mudstone at the bottom of a place where a lake once was.
Yeah.
So we see lots of mudstones on Mars, and this kind of rock could preserve signs of ancient life. If it developed on Mars, a mudstone would be a great rock to look at, because it could have preserved signs that life developed on Mars. Something like this stromatolite could also do that, a chert stromatolite. That's definitely one that could also do that. So we are looking for rocks that might tell us whether life ever developed on Mars. And we think that the rocks might hold the answer. So we are taking all sorts of rock samples to learn that.
Yeah. It's really interesting, like to think about. There may not be a river or stream or ocean there anymore, but you can look at the evidence in the rocks and you can say, hey, how did that rock get rounded?
Right.
Like the thing that we know, we have observed that rounds rocks like that is flowing water or whatever. And when you get to like the mudstone, it's like, that's really fine sediment that formed that.
Exactly.
What is it
Very
that forms?
fine-grained.
Exactly.
Yeah.
So just look, even though it's long gone, right?
Yeah.
The water on the surface of Mars is long gone. We can still look at the different rocks that we can find there and know where they came from.
And there are minerals that we know form in water.
Yep.
And so we've seen a lot of those. There are some cool things on Mars called blueberries, which are little concretions that on Earth they form in water. They're hematite concretions. Spirit and Opportunity found a lot of these blueberries, and so they knew that that place once had water, because those concretions form in Earth in the presence of water.
Are those just like sitting on the surface?
They were sitting on the surface,
wind
and they
has
really
blown
look
the
like,
sand?
yes, they look like little rounded pebbles.
Huh.
They look like blueberries that I put in my yogurt.
Please don't put hematite blueberries in your yogurt.
Yeah,
NASA
they're probably
Spaceflight not responsible for that.
Exactly. They, crack your teeth.
They'd be
That
hard
would
on your
like
teeth, yeah.
Not that fun. Can I show you one more thing? Can I just show you my sample tube? So this is a 3D printed version of the sample tubes that Perseverance is carrying. So Perseverance brought 43 of these sample tubes, and we have filled 23 of them on Mars with different rock samples. 10 of those sample tubes are laying on the surface in a place called Three Forks Depot. So that is in Jezero Crater, and they've been left on the surface, and perhaps a future mission could pick them up. That's actually a backup cache of sample tubes.
Yeah.
Perseverance is carrying the other 13 filled sample tubes. Not all of them have rock cores. One has atmosphere, and a few have regolith, which is the Martian broken
dust.
up, yeah,
Not
broken
really
up dirt,
but
and, yeah, broken up dust and
Regolith
rocks.
sounds cool.
And then the remaining ones have rock samples, and those tubes that Perseverance is carrying are the prime set of samples we'd love to bring to Earth someday.
To get back to Earth. Is that to scale?
This is a full scale.
That's the full scale.
So this is what the tubes pretty much look like. They're actually white with some cool silvery plates, but this is the size of them. And the rock inside is a little thicker than a pencil.
So two interesting challenges there. Some are riding along with the rover. It's like keeping them.
Correct.
It has like a little rack or something, I guess, right?
It does. It has a little rack, like milk bottles on a rack.
Yeah, like a wine rack on the rover. Except
there we
for
go.
Regolith.
Yeah.
And some of it just dropped on the ground.
Yep.
So two interesting engineering challenges.
Yes.
How, if you were to send another mission, could you unload them from the rack? And how, if you were to send another mission, could you pick them up off the ground?
Right.
And then store them and then get them back to Earth somehow?
So we definitely wanted to have two methods.
Yeah.
We'll know about how to pick up the ones on the ground. We'll know that we will pick them up if Perseverance is no longer working. But we anticipate that Perseverance will be working. And Perseverance has a robotic arm inside the rover that moves the sample tubes around.
Okay.
So if it encounters this future spacecraft, which perhaps could be a lander, Perseverance will use its robotic arm inside the rover to serve up a sample tube, and it'll come out the front of the rover in what we call the bit carousel. It'll come right out of the front of the rover, and it could either use its robotic arm to deliver it to another spacecraft, or it could drop it on the ground, and there could be a robotic arm that picks it up. There are a few other, architectures or plans
Ways
being
that you can
studied.
do it.
Yeah,
Like lots of opportunities to solve.
Yeah, so the baseline plan is that Perseverance would deliver those samples to a future lander.
Gotcha.
And if Perseverance is not working, then you have those backup samples on the ground, and so a future spacecraft would go and pick those up.
Go pick them up off the ground.
Yeah.
No
So we're just,
kidding.
we're still trying to work out all the details.
Yeah. It's good to have options.
It is, and it's, there's such interesting challenges, and it's going to be so much fun trying to solve these problems.
Yep.
And they're not problems, they're challenges.
They're not
And
problems.
they're
They're
things that we are going to,
opportunities.
they're opportunities.
Yeah.
Opportunities for more work. And of course, we need, more people at NASA helping us with these projects.
There you go.
Yeah.
And of course, knowing JPL, they're going to be like, all right, we're going to return 5 of these tubes back, and they're going to send something to Mars, and it's going to be like, I have 100 tubes. What do I do with all of them?
Help! I got to juggle.
How can I can't carry all these tubes?
Yes. Well, ideally, we bring back at least 30.
At least 30. Nice.
30.
I just make up numbers sometimes.
Yeah.
Like, I don't know, but I just make up numbers.
100 tubes would be awesome. I mean, because imagine you only have 30 rocks to learn about an entire planet.
Yeah.
Imagine learning about planet Earth with 30 rocks.
What 30 rocks would you even choose?
I know. It would be impossible to choose. And, there'll be long, rock cores of a few centimeters long.
Yep.
We want to share those with scientists all over the world. So they'll be sliced and diced, like slicing up a salami or something,
So they'd be spread around
and
for
then all
scientific
sorts
study.
of different science teams using all sorts of different, machines maybe that haven't been invented yet. So, a diversity of machines and a diversity of minds and a diversity of people all over the country would be studying these rock samples. So it's really important to get them back. That'll be, it'll be a few years from now, but it'll be exciting for like the global scientific community to be able to study these. I'm excited.
Nice. Thank you so much for this. We've monopolized so much of your time
I've
here.
had fun. I've had
You've got a
fun.
few
I'm sorry.
hundred people
As you know,
watching
being a
remotely.
NASA person, I could talk for 3 more hours, so it's good to give someone else a chance.
Do you need some water or anything? It's like
I'm good.
Okay. Chat, we are going to move on. We will let you get back to talking
Sounds
to
great. I'll
other
pass you the mic back.
You can pass me the mic.
Good.
Thank you so much for the time. All right. And chat is saying thank you so much for talking to us. Thanks for answering our questions. Like I'm literally reading the chat here. So I don't know if that's weird, but yeah.
Weird at all.
She said thank you, chat. Here, put the mic at you.
Thank you, chatbot.
There you go. All right. Thank you so much.
Yeah, talk to you.
Let's get Alicia on the stage real quick up there.
Today's or some of our other things later in the week. But thank you all so much again for coming. See you.
Alicia doing her thing, introing and outroing the guests that are doing presentations up on the stage. There's a bunch of benches over on the side, and the kids sit on the play mats in front of it. And
Sorry, I'm doing my job.
I thought we were showing off the job you were doing.
Oh, thank you.
Yeah, we were showing off.
Vamping. I couldn't help but notice a photo booth. I love a photo booth, so I think we need to take advantage of this. You all want to see Das put on some fun
We're gonna go look at the photo
sunglasses,
booth.
so let's go do that.
I don't know if my paperwork covers this.
But then I actually want to introduce you to someone else really cool over here.
You go first. You know
I
these
feel
people.
like I'm a celebrity, or they're a celebrity when we talk. So come here. Everyone's going to screenshot this for life.
What are we
Let's
supposed
go.
to do?
Put this over your eye.
It says tap here for a sun
Just
cell.
look at the camera and just be silly. Put it on. He loves it. He loves it. We're on the sun, guys. We love it. Ham it up.
I can't ham it up. This is Alicia's thing, is hamming it up.
That's true.
Wait,
That's
is
my
that
thing.
a lollipop?
Do you want to hold it up?
Wait, no, it says like, ask me about the sun. Oh no, today I
You
learned
can hold
about
it up.
the
It's
sun.
a photo booth. That's how you use these
You
things.
got sun, you got NASA.
Today I
Kids Week
learned
is fun.
about the sun. I haven't learned about the sun yet. I feel like this is more of instructions, like we should go and learn about the sun at some point.
Well, I want to introduce you to someone else first.
Okay.
All right. So I met this guy this morning, and I felt like I was talking to a celebrity because I think his work is super cool. He's talking to someone right now. It's this guy right here in the white sweater.
Okay. Well, we can hang out again
We'll
for a
vamp
second.
for a second and talk
while
about
we-
the sun,
Yeah,
El
yeah,
Sol.
yeah. Hey, if you're just joining us, I know this isn't like the normal thing we do. We cover Starship, we cover all the different things we do if you're watching on the NSF channel. If you're on the Museum channel, if you're on the Museum's channel, we are at Kids Week 2024. It's live. If you're in New York City,
All week long.
all week long, it's a Kids Week. it's not
17th through
Kids Day.
24th.
Yeah.
It is Kids Week, yes.
She knows
The
all the
first
numbers
3
and stuff.
days are the space days. So if you come out, you too can take fun photos in a sun photo booth with JPL and
It's
look
really
at
bright over here in the photo
Well,
booth.
there's the thing.
The lighting is good.
It's the sun. It should be bright, right? But yes, the first 3 days are space stuff, and then we've got arts and culture. We've got wax sculptures of like Leonardo DiCaprio coming. We've got
Wait, what?
Yeah, Madame Tussauds is coming.
The wax.
Yes, not actually.
A wax sculpture.
He's a little
of-
busy. He's like an Oscar winner or something, or contender. And then we've got animals, of course. We always have zoo animals that come in, and robotics and all kinds of fun stuff. But we are highlighting a lot of the cool space stuff for all you space geeks out there, which we are too. So, I'm going to grab it.
Okay, we're going to grab the next guest.
Can we grab
If y'all are hanging out, thank y'all so much.
Okay.
This is a fun thing to do. It's the 9th year we've been doing this. Right now, we're just running around Kids Week talking to cool folks who can tell
Someone
us cool
let us
space
out of
stuff.
our cages and
Yes.
we're running around. All right, so I would like to introduce you.
I'm going to hand you this.
Oh, okay.
And you talk here,
Okay.
if you can.
Yeah.
Are you good? Hand him one?
Are you going somewhere?
No, I'm just going to check on some stuff
Okay.
in the background. I'm not going to leave you.
All right.
You guys having fun with the sun?
We are. So this is Joby. I'm going to give you this. This
Absolutely.
is a little microphone. Joby is like a celebrity to me. Joby, tell the internet what you do, first of all, what your general job is and what you actually have designed for NASA.
Right. Interwebs, my name is Joby Harris. I'm called a visual strategist. That's kind of a fancy pants term for being an art director. I surround all the different space missions and projects at JPL and NASA with art and design. So, not many people know about quantum mechanics and gravitational lensing and, all of these really PhD level types of things, and I don't even understand it. But what I do is I go in and I talk to an engineer and a scientist and I say, tell me about your mission, tell me about your project. And then we're going to communicate to people what it is and what it does, but through art. So, or through media, through film, through analogies. So that's what I do. So I think you
thing I was
surprised me
geeking out about.
and made me blush and sweat and just like, oh, that's so sweet. I illustrated some posters of other planets called exoplanets, real planets that scientists have found, and kind of what's going on the planets. I illustrated travel posters to these other worlds. And to be honest, they were just meant to inspire a few people on scientists and hang in hallways. And the next thing you know, they leaked on the internet. People loved them, including this fine person
Oh my
here
gosh.
who printed them out or got copies and put them on the
I
office.
think years ago we got lots of copies
Yeah.
that we gave away here at Kids Week, and I have tons of them in my office.
Yay.
So these are the NASA Travel Bureau posters.
Yes.
I think there's like 13 of them that you did.
They keep growing. There's posters. If you want to go to a lava world, you can travel there. If you want to go to a planet that goes around 2 stars, you can do that. So there's a lot of them.
And they're so cool. They're designed. I mean, I'm like an art geek too. So like they're designed in like the 1930s, like national, the wild.
The WPA.
The WPA
National
style.
Park type of you know, they couldn't take cameras to some of these places back then in the 30s, 40s, I think.
Yeah.
So, but they still wanted people to travel to these far off lands, and so they would do these beautiful illustrations on why you should go there. And so, of course, we don't have cameras really on these planets, but scientists can kind of tell what's going on the science. And so we just said, well, what if you could go to a super Earth that has 3 times the gravity of Earth? Well, you'd probably want to go skydive there. So we just did some posters of that, and then find people.
So well, though, it's like there's like the nightlife one,
yeah,
right, where everyone's like at like a nightclub. And
a
it's
planet that got kicked out of its system. There's no stars, so it's just always in the dark and it's glowing. So like, why not just kind of party all night there? I guess. So yeah, we do that.
Really, really fun, and they're still available online too. If
For
anyone,
free.
For free.
For
you can
free.
download them. You can make them your desktop. You can print them out. Where can they? Do you know the website off the top of your head? It's on the NASA website. You can
This
Google
sounds
it.
super arrogant, but if you just Google NASA posters, it'll be the first thing that comes up. It's called Visions of the Future. But there's a lot of, there's also some really cool technical ones on there, like about telescopes and, you know, anything you could think of. People are printing them out, they're putting them on their wall, and they're talking about the science, they're talking about what it is, and that means that I did my job really well, right? People are talking about these things. So
I just think he has the coolest job because it really is that integration. It's STEAM, right?
STEAM,
Something
yeah.
we love to talk about here at the museum too. It's the integration of STEM, science, technology, engineering, math, which, you know, maybe not everyone has a degree in, like you said, or knows a lot about.
I think 2% of the United States has a PhD, I think. So that's probably even being generous. So that's 98% of people that want to understand and be excited about what NASA's doing. And a lot of times art is the way to do that.
It's the universal language, really.
Yeah.
It helps to get across whatever it is you're feeling there, you're trying to get across with it. And it also just goes to show you don't have to be a scientist or an engineer to work at NASA.
I'm not.
He's not.
I was the first one to raise my hand in the room and say, I don't know what you're talking
But
about.
that's okay. He's still got a NASA sweater on. He's still at the JPL booth.
That's right. That's right. They still let me come to these things and represent them. So that says something.
I really wanted to make sure we got you on here because it's so great to highlight that there's other things. There's communications people.
Yes.
Like a lot
we have
of people
photographers. We have photographers. We have writers. We have who else do we have? We have historians. We have people that just work in our libraries that document everything. We even have origami experts, right? We even have people that
for web, for folding stuff.
Well, we got to figure out how to get up into space as small as possible, and then once you're in space, you can get as big as you want. So we even have origami experts that try to figure out the best way that things can kind of fold down and then fold up. You know, then it's up to our engineers. Once it's in space, how does it not break? Right, once it enters that vacuum of space. But we got all kinds of people, all kinds of different jobs. So just, yeah.
Do you have any projects that you're working on right now that you're excited about? That you can tell us about?
Yeah, absolutely. Currently, I'm figuring out a lot of the artwork and branding surrounding a mission called Europa Clipper.
Coming up soon.
Yep, Clipper's going to go to a little moon of Jupiter called Europa. And it's got a lot of crazy stuff going on there. It's an icy moon that's getting squeezed like crazy by Jupiter's hostile gravity, creating energy in this little moon, and there's geysers. They think there's ocean water underneath this ice. So I got to figure out the branding, this, you know, stickers and posters and all of that stuff that surrounds the mission, that talks to people about it and gets them excited about it. So one of the many projects.
That's really exciting.
Yeah.
Europa Clipper is going to be a big one we're going to definitely be talking about.
Yeah, if we find any kind of microbial life outside of Earth in our solar system, it's probably going to be on that moon.
The cryo geysers, we've been talking about that for years. Actually, here too, we've been talking to the students about that, how there's a high probability. That's very exciting. Did you make a travel poster for Europa?
Not for Europa. Some posters for Europa. But yeah, anything traveling there is going to probably be robotic. There's several robotics missions that want to go down into that ice, but all in good time, right? These missions that's the problem with working for someone like NASA as an artist, is these missions take years, like decades. So I could create artwork for something and they're like, no one's going to see it for 10 years, you know. But then all of a sudden I did a project where it's a mission called Deep Space Optical Comms, and they wanted an HD video that they wanted to beam back to Earth via light. And so they came to me and said, we need an HD video. What should it be? And so I filmed my cat chasing a laser.
That was your cat?
Yeah, that was my cat Taters. My cat Taters.
This guy's a celebrity.
Yeah, Taters is my cat.
This is great. Oh my God.
So I literally just filmed my cat Taters chasing a laser, and that became the first HD video ever beamed
I'm
from
obsessed.
space.
I'm obsessed. I
So
love
you
it.
never know.
That's great.
And they told me like no one's going to see it for 3 years, and so I was like, all right,
The
that's fine.
internet blew up
And then
with
all of
that
a
thing. Are you
sudden, like
kidding me? You're
2 weeks
famous.
later, they're like, Joby, they're going to beam it back tonight. So yeah, and then suddenly my cat goes crazy viral, and so
As cats do.
really interesting. You just never know what's going to happen here when you support
God.
support NASA and space. So I'll have to bring Taters here next year.
Yes. Oh my God.
Just have my cat give little paw print autographs.
Oh my
or something
God. Your
like that.
cat's more famous than you are now. Jeez.
Exactly. I'm just gonna let me give him a call. Let me give him a call right now.
Talk to his agent.
Talk to his agent.
Yeah, talk to his agent. Exactly. I don't see any of that money, by the way.
Oh.
So anyway, no, it's fun. It's fun. So definitely, if you're an artist, you can work for NASA. There's a lot of room for you. But you're essentially a communicator.
Something else that people always ask about too is like the mission patches.
Yeah.
How they get designed. Do you have any involvement in that too?
Yeah, I think the mission patch really traditionally has been focused on human flight, right? It's what they wear representing the mission. So if it's a non-human flight, we'll do stickers. And so they're called mission identifiers. But so yeah, there's a style, there's a way to do mission patches. Oftentimes it's done by the NASA centers that do the human flight. But the work that I've done mostly with the branding and identifiers is mostly in sticker form. But yeah, there is a style, right? You want something simple. You want it representative. We're sort of overusing the swoops and the stars. So we're looking to like what can we do that's different but still stay in the family of a mission patch, you know? So it's really interesting to communicate a lot of things in a little tiny simple image. So that takes a lot of work.
I have a controversial question for you.
Okay.
I don't know if I could ask this. As a graphic designer, meatball or worm?
Oh.
Uh-oh.
Well, as a major 80s enthusiast, I'll side with the worm.
I mean,
there's a reason why the worm came back, right? Because people love it.
Yeah.
And so several of my colleagues worked really hard to bring it back as an official logo. It had been retired. And I remember we spoke to the artist, Richard Dane, who designed it and was devastated when they retired it to go back to the meatball in the 90s. And I remember I met him probably three years ago when he was just, the branding book came back out. And I said, when were you not bitter about it? When did you get over it? And he's like, about a week ago. So for that long, right? So I think people love this. There's some nostalgia to it. It's when we were excited about the shuttle program. So I think that's why it's designated for the human flight stuff. That's what it goes on. Like if you go to headquarters now, there's a giant worm logo outside of headquarters. But the meatball, the meatball's the meatball, right? It's NASA. We show up with a NASA meatball sticker and people clamor for it. There's riots.
They're
for
all over
them.
the floor
So
here,
all over,
yeah.
Yeah, they're all over the floor.
Well, actually, literally. No, they just repainted the floor, so they're not on the floor right
now. It's a NASA floor.
But they will be on the floor.
It's a taxpayer-funded floor now. We own it. So yeah, the NASA, the worm, the meatball, always going to be like a.
It's sometimes a controversial thing, and sometimes people are like, I don't know if I'm allowed to answer.
I don't know.
But you're a graphic designer, so
I'm a graphic designer, and it's interesting the names we give things, right? Meatball, worm, logo, right? So it's interesting. I will say that the meatball logo is incredibly difficult to represent three-dimensionally. I would say I've been to several NASA labs, and probably half of the three-dimensional logos are wrong. And there's a way to look and spot what's wrong with it, but you got stuff going underneath swoops and over swoops and stars and all this stuff. So the meatball logo is definitely harder to create into a three-dimensional form. The worm logo is just awesome. It's hard to mess that one up.
Yeah.
So.
It fits on the side of a booster really well.
It does.
It just fits on a booster
booster
perfectly. Yeah, exactly.
All right. Do we have any questions?
I'm scrolling through. It's all.
Are we live?
Yeah, we're live.
Oh, yeah, we're live.
Yeah, this is live.
We don't mess around.
Okay. Yeah, we don't mess around here.
Who wants to interview your cat?
Taters. Let me tell you about Taters.
Tell us about Taters. Please tell us about Taters.
Oh my gosh. Taters loves people. He loves, where anything is. Okay, so quick story about that.
Please.
So everybody said.
Take it away.
Everybody said, we pitched a lot of concepts for this HD video. And we kept coming back to my cat chasing a laser, and they said, but it has to be refilmed better. Like it was literally just a wall and him. So I got all this camera equipment from work and lights, and I set up this whole system. And I put taters in front of it, and I shot the laser, and he wasn't having any of it. I seriously tried for 45 minutes to get him to chase the laser with this good setup, and he wouldn't do it. And I was so mad.
Do it
I
for
kinda
science.
kicked him out of there. Right. I kicked him out of the room, and then I took everything down, and I was going to write an email to the team to say, we need to use stock footage. My cat is not cooperating. And when I walked in, he was sitting on the couch, and I just pointed my phone at him, high HD video, and then he just went crazy. So it had to be on his terms. He's that guy. Like, you know, I'm still working through the contract with him. I don't know what all's involved now that he's famous. But anyway, no, it was a lot of fun. And I'm glad I didn't name him something controversial, right? Taters is taters. So no, it's a lot of fun. It's been a lot of fun. So I wish everyone's pet could go viral for something as meaningful as being the first HD video beamed from outer space. But we did that because Felix the cat was the first television broadcast image. It was the first test image. So when they were testing television, they used a Felix the cat image. So that's why we wanted to go back to the Taters the Cat video to kind of stay with the future of comms and things like that. So there was a reason to it. It wasn't just because of that. So anyway, all right. If you all haven't switched over and off from the live by now.
Oh, you're amazing.
Oh, you're always live?
No.
Live all the time?
No.
Oh my gosh.
So
we got robots behind us. We got chaos all around us. It's chaos at the Intrepid, ladies and gentlemen. Get down here.
It's glorious chaos. It's good chaos. Please come. Please come.
Rolled over Jason's foot.
We're having a great time here, guys.
2 more days of this. Please come down.
Yes. Well, and all week, but the space stuff, 2 more days.
All week. Well, we're here for 2 more days.
That's right. And you don't want to miss Joby, and you can talk about taters.
Please
with
come by.
Joby.
Say hi. I'll show you pictures of taters.
Oh, and our friend is
Rover's like horning in on the conversation.
Oh my gosh, I love it. All right, any other questions for Joby right here?
It's all cats.
All right, it's all cat. Everyone loves your cat. Your
We
cat's
open the door to cats.
Sorry.
He's amazing. His favorite toy is little plastic springs.
As they do.
And
yes.
markers. He likes to knock my pens off the tables. It's just normal cat
Our
stuff.
cats sometimes make appearances on NSF too. I know mine does. I force him to appear on This Week in Space Flight. Sometimes he's like, ah.
Yeah. So, thanks for having me. This is fun.
Absolutely. Thank you so much. This has been amazing.
Totally.
When
All
we're
right,
done,
everyone.
we just point the camera somewhere else.
Yeah, we don't stop.
I don't know.
Can't stop, won't stop.
Yeah.
All right.
This is mine.
That
It
was
is-
yours.
yeah.
All right, thank you. Oh my God, I didn't even realize
I
this
know.
was a cat. Oh.
You like dragged us over to talk to him.
I thought his job is cool because it's art, and like he designed the travel posters, which I have them in my office. I love them; they're so cool. And then taters. My mind is blown. Oh my God! All right, where should we go next?
I have no clue. Where should we go
let's
next?
go over here. NASA Marshall.
Okay.
They've got this cool VR rig over here. This is Planetary Missions. They've brought this a few years.
The VR rig is always popular.
It
right?
is.
Everybody
It's a
wants
one person at a time.
Yeah,
There's
yeah.
always a line, but
Let's head that
she knows
way.
we're coming though. So. Trying to figure out the best place to be for us to be able to be. When you're done. You can load him up. If that's cool. So, oh, great, awesome. All right, so I mentioned before, we're just kind of roaming around. We'd love to talk to all the different divisions and about what is the big things that you're pushing right now. What do you have here? But what are the big missions that you're working on? So, yeah, I'm just going to hand this to you. Your microphone.
Okay.
And take it away. Introduce yourself to the world.
Hi, my name's Stephanie Henry. I'm the communications lead in the Planetary Missions Program Office. We're located at Marshall Space Flight Center in Huntsville, Alabama. NASA has 10 centers, and so we're the one in Alabama, and then you'll find the others all across the United States. In the Planetary Missions Program, we manage different levels of missions. So if you heard about the OSIRIS-REx mission that just brought back a sample of the asteroid Bennu, That's one of our missions. We just launched a mission to Psyche, and it's an asteroid that we believe is made out of metal, of nickel and iron. It'll take us about 6 years to get there, but then we'll learn all about that. We think that Psyche could have been the core of a planet that broke apart, or it was part of a planet that was forming that never fully formed. And so it could be very similar to the core of Earth. So we want to know more about it. And today we have a virtual reality arena here, and it gives visitors the opportunity to teleport around the solar system and learn about some of our missions. We start off at Mars, then we go to the Sun, and then you go to Jupiter, Saturn, and then we head to Earth, and then finish it up at Pluto. Is that good? You want anything else?
Wait. Oh my gosh. We left you hanging. I'm so sorry.
Okay.
We were planning off camera. Hi.
Yes, hi.
Yes.
How are you?
I'm good. Where were we?
Yeah. So I gave a little intro.
So I was talking to Daniel,
Yes.
your colleague earlier. So
Yes.
he was saying, so you were saying Psyche, you've got Osiris
Right.
Rex,
Yes.
and then Europa Clipper coming in.
Yes, Europa Clipper is going to launch on October 10th from Kennedy Space Center on a Falcon X, Falcon Heavy. So we're excited about that mission. And so Europa will be neat because could be signs of life there because there's ice. So we're going to go learn more about that.
We were just talking with, we
were just talking with Joby, who, I didn't catch his last name, who designs a lot of the artwork and whatnot.
yeah.
He was saying, Europa Clipper is coming up, and that's going to be something exciting to look for because the cryo geysers and there could be life and everything.
Right.
Tell us more about, so Psyche happened, and then Psyche is now getting repurposed.
No.
I'm sorry, not Psyche. Osiris Rex is getting repurposed
Yes.
to Osiris Apex.
Yes, Apex. So what's happening is Osiris Rex dropped off the sample in Utah in September, and we just about 3 weeks ago were able to open the capsule, and they just released the data about 2 days ago about how much was in there. It's about 120, I believe it's grams that are there.
A lot more than they thought, right?
A lot more.
Like the target.
Yes, a lot more. And then, so it's going to continue. It has an extended mission called Apex, and that means it's going to another asteroid called Apophis.
Right.
So.
And that's the one that's supposed to hit us someday, right?
Oh, God.
Maybe, yes. Maybe in the future, yeah. So.
We won't be around for that.
Yes.
But it's just sort of still going on its trajectory.
Yeah. Changed trajectory a little bit and started heading to Apophis.
So what are they hoping to find now with the collection sample? What are they looking for specifically, and what have they found so far, if you know?
Well, they're looking to see what it's made out of. It's a carbonaceous asteroid, to see, what minerals are present. And so they're going to take 200 samples and send it out all around the country and to other countries, and they're going to let all those scientists test it and see what it's all about. And then they'll collect all the results. And they're only using about 25% of the sample right now, and they'll save the other 75% for future generations to investigate.
Have they done something like that before, saving samples for the future?
There's an old mission, Stardust, that was a long time ago, and it sampled something. But that's about the only other one.
Some of the Apollo missions, too, like they kept them in storage until technology got better.
Yes, exactly.
So we wouldn't crack open the can in the 60s, 70s, like we saved them till we got better technology to study them.
Yeah. It's exciting. We have a lot of exciting missions and science happening.
Yeah.
Awesome. And what do you have here at Kids Week now behind us here?
So this is our virtual reality arena, and we love to bring it to the Intrepid. And so the visitors can step inside, and they use their controller to teleport around the solar system. And so they start at Mars, and you can just walk around Mars. And then we get to the sun, they press the button down and point to the ground and make a laser. And when they get the laser just where they want it, they release it and they teleport to the ends of the laser. When they get to a planet, like she's doing right now, you can reach out there and pull the trigger and you can pick up the planet in your hands. So it's really just something to inspire kids and get them excited about science and planetary exploration. And hopefully they'll go learn about it and check out NASA.gov.
I like the safety rails around the walking area.
I'm very excited just now.
You need the rails.
That's very cool. Yeah, we love having this here every year. This is always very exciting for the kids.
Yeah, chat is wondering if it's okay to teleport close to the sun. You just have to go at night.
Yeah,
or bring your sunglasses.
You can actually walk inside the sun.
Really?
Yeah.
You heard it here first. NASA says you can walk inside the sun.
Yes, absolutely.
Totally safe.
Excellent.
On the VR.
On the VR.
Yes.
What do you work on specifically? You gave a little intro at the beginning, but...
Yeah, so I'm the communications lead, so we manage all the communications products, outreach, social media, the website, and we really travel a lot and go to different events to talk to the public about our missions and to get them excited about science, technology, engineering, and math.
Very cool.
What are you most excited about coming up?
Ooh, yeah, I think Europa Clipper will be great. That's a big mission. And then we have a mission in the future. They're still working on confirming it, but it's called Dragonfly. But it's a quadcopter that will go to Titan, Saturn's moon. So that'll be, I think, very neat.
It sounds slightly ridiculous when you say that. It's like, oh, it's a quadcopter that's going to Titan.
I know.
Really?
Yes.
It's so cool that we're able to do stuff like that.
Yes. So we get new missions every 3 years or so, depending on which class of level they are. So we're constantly adding something new and planning for it.
Nice.
So.
Excellent. Well, so I'm reading chat over here. Sometimes people, they think I'm being rude, but we're live, and I'm reading questions from chat here. Oh, yeah, can we hand that to you?
Yes.
There we go. We're super fast and loose here. It's just like, here, have a microphone.
I'll do my best.
So, if y'all had any questions, put it into chat here. But there were some people talking about the VR.
Yeah.
Like, was this something that NASA developed as part of the outreach, or is this something that, like, trains astronauts, but then it's repurposed for this? Like, where does this come from?
So this is something we had developed just for our office.
Right.
And so it's definitely, we don't use, this is the Vive headset.
Right.
So we don't use it for any kind of training, just for this outreach, just for outreach purposes.
Gotcha. So the app that the experience, I guess, that the kids are going through was developed for things like this.
Yes.
Right.
We developed it and put the content in there.
Nice.
And unfortunately, it's not available publicly.
You can't like go to Steam or anything, or like Vive Store or whatever.
Right.
Yeah. That's another important thing, right? Like, yes, we want to fund the missions and we want to have the money to build the Dragonfly to send it up. But designing stuff like this, developing stuff like this, coming to events like this so that kids can get into this and see what's going on, that's super important too, because they're going to build the next missions.
That's right, exactly. They're our next workforce. So as everybody's retiring, we're getting ready for the new workforce to come in. So that's really one of the exact reasons we do this.
Yeah, it really is. Like, it's so important. We're online.
Right.
And so we get comments from people like, oh, NASA shouldn't spend money on that. Of course NASA should spend money on that. Like, we want kids to be excited about this. We want to see the things that are possible. I mean, you could start off with something like this, and there could be astronauts training for a moon mission. There probably are astronauts training for a moon mission for Artemis that use maybe not a commercial gear, but similar sort of setups.
They definitely use VR, yes.
It's a big thing that I talk about a lot because people are like, oh, video games, what a waste. Well, I played a lot of Kerbal Space Program. You can learn about rockets from Kerbal Space Program. And then I hear from people that went on to college to get a degree because they were playing Kerbal. And then they come and work at NASA or they work in private industries.
That's right. And think about NASA, there's lots of jobs. It's not just scientists and engineers. I was a teacher, you can do graphic design, you can be an attorney, an accountant. So we really have all professions there. So it's really for anybody.
It really is the biggest thing. Like you don't have to be an engineer. No. You don't have to be a math nerd to contribute to what NASA does.
Right. I was a teacher, and I got lucky and got a job over there. Now I've been there for 16 years. So,
what did you teach? Can I ask what you taught?
Yes, I taught middle school.
Middle school?
Yes.
So. Was it a science-related field?
It was science.
It was science.
Yes, science.
Okay. So middle school.
To middle school science teacher.
Shout out to middle school.
We love you.
That's right.
So you'll bring a middle school science teacher to NASA Marshall. So many people, especially young people, may look at it and say like, oh, I could never be part of NASA. I can't do that. I'm not smart enough. I'm not an engineer or whatever. But that's not how it works.
I never thought I would work at NASA either. So I feel like I got really lucky, but I think anybody could have that opportunity if you just find that right area that you want to work in.
Yep. There's so many different skill sets that go into doing what humans turns out.
That's right.
I'm unlocking my phone so that I can see if there's a thing. We may have had a couple hiccups. There. It might be because we have a lot of people around us there. But let me turn around. We may need to actually here, y'all. So we will say thank you.
Okay.
So much for the time.
All right. Thank you so much.
And let you get back to the VR
Okay.
experience for the
Thank
kids.
you.
Oh, there you go.
Amazing.
Nice.
All right, let's troubleshoot our
Yes.
our issue.
There was
Thank you
just
for
a big
standing
crowd
by.
around the back
Yeah.
of the camera here. And let's
Well, let's
walk
head
out
on
of the
over
crowd
here,
and we should be fine over this way. Y'all, thanks for letting us know. Like, that is part of it. We don't, like, shut down the museum or anything like that. We're in the middle of Kids Week. And we knew... How are we now? Like, how many 5x5s are we now? Can y'all hear me now or no? I'm actually going to stand by until I see whether we're good to go. All right, how far behind am I? Seems to be slowly degrading. That shouldn't be a thing.
Much better now.
Yeah. We walked out of the crowd. I mean, that's literally what it is. We were in the VR area, and there's a huge crowd around the VR area. This is better.
Okay.
Yep. We knew, like, we
did
sort of
good things.
we telegraphed it, and we said like, oh, the VR area is always super popular, I guess. And then there was a huge line and crowd that crowded around Jason's back here. So, yeah, there we go. Now we're 4x5, 5x5. I don't know, producer, we need to reset the source or something like that. That might be a thing. Let me look at the pack real quick. Hang on.
I'll vamp while he's doing that.
Yeah,
Guys, I'm excited about Europa Clipper. I have some fabulous Galilean Moons of Jupiter earrings that I am going to pull out for This Week in Spaceflight when that thing happens. I'm just letting you know. I am prepared.
Like, This Week in Spaceflight leaks.
This girl's got earrings. All right. Did you notice
Wait, what
them
are your
today?
earrings? Yeah.
What do you think they are?
Subtle earrings.
Of course. These are from Australia.
Really?
Yes. This is an Australia. I'll give them a shout out. They're not free. I paid for them. This is Erstweiler, I believe they're called. And yeah, they have all sorts of cool stuff. They actually did a whole campaign, I guess, a series of stuff that they released that was all like retro moon stuff.
Yeah.
So they had shuttle things, and I have a couple pins. It's like the command module going around the moon,
Nice.
and like the view of Earth through a porthole. Like, they're fabulous. Very like retro-y stuff. They do a lot of like animals and like funky, like, you know, KitchenAid mixers and stuff. But no, the space one, I was like, oh god, I need this. Anyway, are we good? Should we keep moving? No one wants to hear about my earrings.
I want to reset the feed real quick,
Okay,
y'all.
we're gonna do that.
We're not going to stop the stream, but what we're going to do is we're just going to stop our camera output and restart it. It got a little confused when it was all in the people, so the best way for us to reset it is literally turn it on and off again. So producers, Jay, I think is clicking the buttons today. Could you just take us to the standby screen real quick for 30 seconds? We're going to stop our video output. We're going to start it again. When we come back, we'll make sure it's good. We haven't even gone through half of the booths. There's like another half of the booths over on the other side.
Star Wars people left already.
Jeez.
Oh well.
They operate on like Tatooine time or something. There's two or three suns. Like, how do they even do that?
Souls. I guess they have souls. Like on Mars, right? I don't.
Let us reset the feed real quick. We'll be right back.
We'll
okay?
be
Just give us the Kids Week banner real quick, and we'll be back. They're playing the smooth jazz now, and Alicia needs to know her mic might be on. The mics might be hot again.
Hello.
We'll see. Let me go tell Jason to come this way. All right, we're live. And we're back.
Are we back?
Kids Week. We're getting to the end of the day here. It's like after 4 o'clock. What time does it close?
5 o'clock.
5 o'clock. Yeah, it goes till
10 to
5
5.
o'clock.
10 to 5 every day.
10 to 5 every day. But how are we now? We reset our camera feed here. Again, we're... Oh, the speaker. I'm like, are we dancing? Are we moving? 5x5, propulsion's nominal, perfect now, nice and clean for now at least. Sync looks better now. You want me to clap? No, I'm not going to clap. Do we have some more folks to go talk to?
Yeah, actually, I just realized I want to take you over here real fast because there's something that you shuttle fans are going to love over here.
What is this?
Hi. Can we bother you for 2 seconds? So, I'm with the museum, and we do this live stream during Kids Week where we just like to show what's going on around the floor and interview kind of the partners and everything.
We're actually live right now.
We are live right now, sorry. You look fabulous, don't worry.
FYI. Yeah, no
so,
pressure.
Faro Technologies is super cool. They came and they did 3D scanning of our entire ship. And we are using these scans to do all sorts of cool programming, which I don't know 100% yet what we're doing because I think they're still dreaming it up. This is the future. They can come up with cool stuff. But I specifically wanted to point out, because it is Space Day, do you have the shuttle thing? Can you show us?
So what we've got is...
Here, can we hand you that?
Sure.
Yeah. But you can clip it to your shirt if you want to, or whatever you want to do.
And get this on here. So what you're looking at now is the shuttle. So we had scanned this a couple of times. It lets people see what it looks like. You can cross-section. You can see the ship in detail that we've never seen before. Some of the decks that we've seen. And then what we've done is we've, to make it fun for the kids, this expensive, high-tech, expensive equipment takes a lot to learn, but they've recently put this stuff into iPads and iPhones. So for the kids, we've taken the space shuttle, we put the VR headset right there, so they can walk around, they can fly around the space shuttle in VR and see what the scan data looks like. Or we can scan using an iPad or an iPhone some of the artifacts from the ship, and then they can create little 3D images and 3D models themselves. So what we spent years doing and learning, they can do it with an iPad now. So it was a fun way to get kids introduced to 3D awareness and spatial technology. So it's fun.
Can you fly us through the shuttle a little bit? Can we see it?
We can. I'm just gonna.
That's what everyone really wants to see right now, I think. Don't worry, guys. I got you.
So I won't do it with a headset on. I'll have to restart this again.
That's fine. You can start from the beginning. We're good.
There you go. So that's kind of what it looks like.
No kidding. That's like as it is, because it's got the little bollards and stuff around the base. That's like in the pavilion.
Yeah. So I'm going to try and do this with my mic in my hand. So you can kind of work your way through. You can go underneath, and you can also go up and through it. So we have some of the inside the cargo bay here. You can kind of fly through and see some of the. Now this is scanned without color.
Yeah.
Because we did some of the scanning without color in here, but you're definitely seeing. This is a millimeter accuracy too.
No kidding.
So to be able to fly down and into the various parts of the ship. I'm going to put this down so it's a little easier.
Yeah, that's fine.
I can look at it. There you go. So we're up inside here. So you're so. Well, yeah. So this is kind of an idea of where we went to scan. We had to walk across this little wooden area here. And there's actually some people in here that were actually working in the ship. There's some bodies still in here. We can see at the end of this.
Hopefully they were alive.
So there's somebody.
Bodies left there.
There's somebody just hanging out at the end of the. You can see the legs. So you're able to kind of move through the space and sort of see what's there. So it's kind of cool way to get kids interested in, like, as we use this technology for historical preservation, for all the police forces, public safety use it, engineering, all sorts of stuff. So once you have the scan, you can do so much with this.
How do you scan it? Like, what technology do you use? Is it like...
You have the scanner right there.
Oh, it's behind it.
Yeah, it's a LiDAR scanner. So there you go. Sorry.
Thank you.
So what you can do is you basically, the scanner can see what you can see. So if you put the scanner up here, it scans 360 degrees all around.
but it can't see behind you. So we have to move it around and scan again. And then the software then looks at all the geometry around about, and it finds the same geometry in this scan, and then the next scan, and then the next scan, and it ties it all together. So what you're looking at here was probably about 15 scans maybe that's just been all tied together into one point cloud. So and what the laser does is it shoots out from the center of the machine, and it hits something, and then it bounces back. So it knows how far that is based on how long it takes to get the reading back, and it drops a little point with a coordinate.
Exactly where it is.
Exactly where it is. It does that 1 million times a second.
No, 1 million times a second?
Could do 2 million, but for this we did it 1 million.
Well, they slowed it down to only 1 million times a second. Nice. So like, think of that. Like, do y'all understand what's going on there? If you have the scanner over here and you want to scan the laptop, if you scan this way and it hits this, it can't see what's over here. It's like playing Battleship, right?
Exactly.
Like playing Battleship, right? And so you take this scan and it gets all these points on exactly where that is. Then you take the scanner and you put it over here, or maybe up here would be better, or something like that, like angles. And you scan it from here, and then you get this side with the keys and everything like that. And then the software puts it together, so you can look at this and you can be on this side or over here or whatever.
Absolutely.
Kidding.
You can jump into individual scan positions. So when you're...
like where the scanner actually was?
No, there is no one for this one. Yeah, you can jump into, so you can see all the different scans that were here. So you can jump into any one scan position.
Yeah.
And then you're seeing what that one scan saw. So that is just the points that were captured from one scan.
So it has color to it.
So the color, we can scan with color. Without, we did the outside with color, the inside without color. Because it takes, the longer it takes to scan it with the color, so we wanted to get in and get out quick. So the outside has color.
So this isn't just a 3D video where it's like a really wide video that gets wrapped around. This actually knows the distance to every single thing in there.
I can measure anything in here down to millimeter accuracy.
No kidding.
It's helpful for us too with the ship, because it's like for you know, special events planning and stuff. If we need to know like how far a table is or whatever for something, we're actually now using these to help us at the museum too, as well as use it for educational things.
You can, once you start using it, absolutely, you can find a million things. I'm going to show you the 3D view from this one, just so you can get an idea of what one scan looks like.
Sure.
So this is what that same scan looks like. Just takes a little minute to come in. So that looks just like what you saw.
Yeah.
But as soon as I do this,
oh wow,
you can see it looks a little different. There's nothing
you can
on
see
the other
lines,
side.
like the lines from that one. Look at that.
But there's nothing on that side. It's just one scan. So we would have to scan all around that and then pull them all together to get that final. So that's what one single scan looks like. And then we combine them all to look like this.
Maybe this is like a silly question, but once you've got a 3D model of it, right? Could you export that to like a 3D printer or something? Probably not what it's for, but...
Yeah, absolutely.
No kidding.
I scanned a little house where my family lived in north of Scotland. Data to sort of set the stage for shooting. So they'll have a point cloud, and the actors will be immersed in the point cloud. It's projected on a 360 screen. So you'll see the Mandalorian and little Grogu on the middle of this. And then when the shooting's done, the 3D, the effects teams come in, the CGI team.
They put it in.
They'll use the data as a basis, and then they'll fill it all in and make it look real. So
no kidding.
Data can be used in a million different ways. You just have to think of them. And that's one thing that the ship's been good at. They'll say, what can we do with this? And brainstorm ideas of what you can do with this amazing data set that you've got.
Well, and what's really cool, I'm just going to keep talking.
Just take it.
What's really cool too.
She has to talk to Milo. Oh, there you go.
We only have 2.
She's just going to take it.
We got to get 3 next year. No, what's really cool too is that the ship is so big, right? The ship is gigantic, and only a fraction of it is open to the public right now. So what's great is that you guys were able to scan some of those off-limits areas, and now we're going to be able to make that accessible to people, to see, and we can recreate spaces and maybe what it looked like via virtual reality, or I don't even know what they're going to dream up to do it, but it's going to be really cool for the ship too.
I've seen some sneak previews on what they're going to be doing with some of the data, and it looks amazing.
Yeah,
the exhibits team have really wrapped their head around this and are thinking up some great ways to use it.
That's awesome.
It's been fun. One of the exhibits, actually, the Corsair, the propeller. They had called and they said, well, we've got this propeller, but we have to build an exhibit for it, but we can't touch it. So they needed to build mounts for it. They needed to get to be able to support it. And so we said, well, why don't you scan it? So they scanned the propeller, and then they were able to bring that into design software and figure out how it was going to be mounted, build the structure around it, and it's sitting in that case over there.
Yeah.
So it was just one of those things where they were thinking, we'll scan and try it, and it works. They brought it into design
Could you
software.
imagine like doing something like that? You land a rover on Mars or whatever. You scan the terrain of Mars or whatever, and then you can send like a pre-made hab in to fit the exact specs of whatever it is. Like, this is amazing work that I just think this is so cool. We love having you here. Thank you for giving us the tour. This is great. That's really cool.
I want like
That's
a
really cool.
like a 3D model scan so I can print out.
You know what?
from an
It's not
actual
just
scan.
you, Chris Bergen. I'm sure you're watching. You're going to want that one too, right?
Well,
so many shuttle
scan
fans.
you, and then everybody can take a turn spinning you around.
They'd make a
3D
bobblehead
scan
or something,
does.
what they would do.
3D scan does.
Scan people? Like, do you have to hold really still, like an
You need
old
to hold
photo?
still. Oh yeah, we don't scan pretty well, and then we can all spin you around.
Madame Tussauds is coming on Tuesday and Wednesday. Maybe you guys could do that with celebrities or something for them.
Scan the wax model
sculptures.
than a real person. I tend to move and.
Well, I
fidget
meant
a lot.
scan the person for the wax model, but I guess you could scan a wax model if
easier
you
to
want.
scan. You already have the model.
Well, they're not going to move; they're just wax.
We did a presentation with a company one time where I scanned the room while they were in the room.
Yeah.
And then while somebody else was talking, I processed the data and we moved it into some computers with headsets. And then within a half an hour, we moved the people from the room. There was about 50 people, and we put a headset on, and they were able to walk up to themselves in VR.
Oh, that is crazy!
And they were a little bit freaked out, but the fact that the technology did it like that, it was
No kidding.
That's cool.
So it's not like you scan it and then it takes weeks to process it. It seems pretty fast, I guess.
Depends on the volume of data, but a couple of scans for just in a room full of people, you could scan around here maybe half an hour.
No kidding.
But just a couple of scans, 1 minute, 2 minutes each. You can do it pretty quick.
And it takes a minute or two to do it, like.
It depends. Again, that scanner can scan. You can do a 30-second scan. You can do a 90-minute scan. So it just depends on what you're using the data for, how much you need.
The microphone.
We would do a 30-second one.
A 30-second. Oh, I'm only worth 30 seconds to scan. Not 10 seconds at least, but I don't get 90 minutes.
30.
I'd have to hold really still. Like. No kidding. I'm going to look at my phone and see if there's any questions for people.
Yeah, if anybody has, like I said, an iPhone with LiDAR on it or an iPad with LiDAR, there's a number of apps. There's Sitescape where you can actually go and create your own scan data. It's not quite as accurate as this, but it's fun.
Really?
Scan a room. Kids can scan these things. It's in your phone right now. There you go.
I'm trying to get the questions here, and people are interested in the model of Enterprise. Of
course.
That's something the museum.
Maybe we can sell them at a premium.
Work on, in the shop. It's like come through and get a thumb drive.
Get a thumb drive of the scan.
How big is the scan?
How big is the scan?
Yeah, like how many megabytes or gigabytes or whatever.
Oh, it's big, isn't it?
No, it's not that big. So you're probably looking at about under a megabyte.
What?
You get them like depending
The
on
whole scan of the ship for under a megabyte?
The scan of the whole ship.
Well, the Enterprise.
So
but one scan.
The Enterprise.
For one scan, yeah. For the ship, I think we were around 8, maybe 9 terabytes.
8 or 9 terabytes.
That's slightly different.
There's a lot of scans of this ship. So.
No kidding.
Well, it's a big ship.
Yeah, it is a big ship.
Small scans, you can, they don't take up a lot of room. Not too bad, but.
Yes, I say no kidding a lot. I get it. People are reminding me that I really get interested in stuff. I'm like, no kidding. I'm fine with it. Let's see. Any other question, like actual questions? Have you scanned any other shuttles?
No.
No.
Just this one.
All right, okay. I guess Intrepid is okay with that, but people are interested in scans of shuttles. this is a commercial technology.
It is.
So you scan places, like somebody will hire you to come in and scan a facility or something like that?
So we don't do that. We make the scanners and we make the software.
You make the scanners. And then
So-
companies do that, I guess.
Yeah, so we sell the scanners to companies, to law enforcement, like I said, accident recreation. They'll
Yep.
scan an accident, or so all sorts of people use it for all different things. And then they, once they have that in their technology, they can use it for lots of different things. But we don't. We just make the hardware and the software.
Nice.
Sell
Okay.
it on to them, and then they can figure out what they want to do.
Gotcha. So, like, in the course of making the hardware and software, you need things to scan, and your technicians may come and scan like this sort of thing.
We do a lot of testing, we do a lot of R&D, and always trying to come up with new, better ways to do things. You know?
Nice.
So
All right.
it's the VR was a nice touch too. I remember when that first came out. That was kind of cool to play
Like,
with.
once you have the 3D data, like, porting it over so you can experience that way instead of just on the flat screen is a totally different thing.
First time we did it, you could just teleport, and then you look around, and then you teleport and look around.
Yeah.
And then when they made it that you weren't tethered, you could free fly. I think I did about the first 10 minutes, and I was ill for about 2 hours afterwards. It was like some lady said it was like reading in a car.
Oh, thank you.
An emotion sickness is something.
I tried to play Minecraft in VR, and I'm like, oh, I can play video games. And like 10 minutes in, I was like,
no.
I really, like, I'm not moving, but I'm moving, but I'm not moving, and my eyes say I'm moving.
No,
So.
it's after a little while, it just feels like it just gut punch.
Yeah.
But it's fun.
Let's see here. Yes, I am interested and astounded by an answer thus confirming that the guest is not kidding. So there are some apps. People asked you what the apps were. They're not made by y'all.
We have one called Sitescape.
Sitescape.
There's a bunch out there. Polycam. There's things like Scaniverse. There's a bunch. Basically, if you go onto your app store, and then just take a look for LiDAR scanning, and there's a bunch on there that will come up, and you can. Most of them have trials. You can try them all out.
Sure.
Find anyone that you particularly like.
Yeah.
Some of them, ours just uses the LiDAR, the point, so it looks kind of like this.
Right.
Other ones use the photographs as well, which is kind of making it look pretty.
Yeah.
So there's all sorts of different things.
Like, it's the color data along with the LiDAR. Is that just on Apple devices that have that LiDAR?
At the moment, yes.
showing full bit rates.
But it's dark in there, and like it's.
I think we might be live again, Alicia, just so you know.
Are we?
Yeah.
Hello. Yes, I was just telling her that the inside of the shuttle is not something that we have open to the public, obviously. As you saw, there's literally a wooden plank down the center of it. It's not like the other shuttles because it's the prototype shuttle. So the inside is guts. It's just beams and stuff. And so, yeah, we were just saying it's dark in there and it's black and white. Obviously, it's a little bit difficult to see, but it's a cool thing to be able to show people now, to give it a little bit more of an access.
So the reason part two is about the scanning with the color. If you're in a dark area with zero lights, you can still scan and see and walk around without needing lights in there, because it's just taking dots. So you don't need to have lights. So it's interesting to go into places where there are no lights and still be able to come out with something that you can really see all the detail. It's kind of cool.
We mysteriously came back all of a sudden.
Okay.
So,
so we're good?
Yeah, we're good to go.
Thank you so much.
But now we just want to say thank you while we're live.
Thank you. Yeah. Amazing. She'll be here all week too. So hey, if you want to see the inside of the shuttle, hop on a plane. Come to Kids Week. You can see the inside of the space shuttle, Chris Bergen.
Chris Bergen. Nice. Thank you so much. Sorry for the tech hiccup there at the end. All
right, let's head over this way.
We're going to walk this way.
Yes, I've literally been staging the next group here now. So we are going to go talk to NASA Hito.
Hey, real quick, let's time out for just a second. Thank you all for bearing with us.
Thank you, yes.
We don't have a huge crew or anything doing this, and so when we have little technical hiccups, we're trying to share this with people so we can share it with you, right? When we have hiccups and y'all understand that we really do appreciate you working with us, just tell us. Just be like, hey, there's a thing, because y'all are sort of our remote production crew for events like this. We're not broadcasting a launch or anything like that, where we'd have a lot more cameras and we have standbys and fallback connections and stuff like that. We have one backpack with one camera, Lisa and I running around talking to people. And Jason.
One Jason.
One Jason.
And if you're watching this after the fact, just fast forward. It's fine. It's all good.
Yeah, but thank y'all for understanding when we have little hiccups like that, because we're just out here sharing it with you.
Can I grab you actually really quick? We'd like to highlight your space shuttle.
Oh, good.
Yes, please do. We have a little bit of time to walk. As we're walking past here,
what are we doing?
We're gonna walk this way, but we
He
can't.
had food, and you
we
pulled him
can't
away from his
ignore
food.
this. I know he can chew. All right, so you might notice as we're walking past here, we have a giant balloon sculpture of a space shuttle. I had to. This is John Reed.
Hi.
And he created this amazing thing.
Tommy May from Balloons Inc. My buddy Justin, Julie has been over there with Vinny doing all the balloon twisting for the kids, where they're learning how to make a balloon dog. And that's going to be the flames that come out of the bottom of the ship. So
it's an ongoing process.
This way the kids can be part of the story. The best part about something like this
we'll
is
get the shuttle so they can see the shuttle too.
When they get to be part of the story. For me, that's, I always wanted to be part of it. I was like, well, I want to help. Now the kids can help. And when they throw their dog in, they're going to look for their little red dog that has a tail that might be a little too long, or they're a yellow dog that is, got no legs because they forgot to put legs on it. But they'll get to see their dog in there and be part of the story. And frankly, I don't have any fingers left after this to make all the dogs to make the flames on the bottom. So,
but this is so cool. We've been seeing this being created.
Yeah, here we go. Let's turn around this way.
We've been seeing this being created since. What time did you start? 9 o'clock.
We got here a little about 9:30, and we got right in on it and from scratch.
This morning?
This morning.
No kidding.
We've been building it all day.
This was about 7 hours of build time. So Tommy took care of the boosters and the fuel tank by herself. Justin and I knocked out most of the shuttle.
It's the coolest. Thank you so much. We were so excited for this.
6 years of college, I do this instead. So my mother is thrilled. Stay in school.
I was a theater major, and I'm doing this.
So actually, both Tommy and Julia are theater majors.
There you go.
It's art.
We were just talking to somebody over at NASA JPL who designs, the art and the posters and everything. His cat was the one who got beamed through space, the laser, the video, Taters. Shout out Taters. So, you can do stuff like this. You don't have to be a scientist.
If they come down, they can learn how to make a balloon dog and be part of the story. That's the best part.
Nice. This is like the best
elephant
kind.
in the room.
This
I
is
had
like
to.
it's the best kind of inflatable shuttle because they have the ones that have the one blower and it's like, hey, all right, that's kind of cool.
So the fun part about this is anytime you make a big sculpture like this, all the kids are like, can I have a balloon? And I don't want to be the guy that's like, no, you can't. I need them all to make the shuttle. So being able to have them go and make their own, they leave with this sense of ownership for also being able to do it themselves.
No kidding. Do you think the shuttle would survive re-entry?
Probably not. Yeah, it barely will. It would barely survive exit of the hall.
Exit of the hall.
So I give it 18 feet before it starts to come apart.
Can we try to launch it or something? They're just air balloons, right?
If you poke the bottom, they'll go fart flying all over the air.
I love this idea. Can we do this at the end of the space days?
So that for me, everybody's like, aren't you sad when you have to pop them?
Yeah.
Nope. I have blood, sweat, and tears are actually in there, so it's a little bit of
it's a release.
Yeah.
But we don't want to pop it right now, though. We want to. This is amazing. We want this to last as long as possible. This is so cute. Anyway, it literally. I mean, it's the shuttle in the room. It's the elephant in the room. I had to point it out. I'm sorry. I got us distracted, but thank you for. We just wanted to highlight. Thank you. All right. So
I didn't read
now,
on any
course,
chat on that one. We're just following Alicia.
Sorry. You would have asked.
No, we had to.
People would have noticed.
Well, I saw it when they were making it earlier, and I was like, is that a balloon SLS? Because I could only see the other side. I couldn't see the shuttle on this side, but they're close enough. Alicia's getting another victim here.
All right.
I mean, volunteer.
Hi. Hello, everyone. So, yeah, it's nice to see you again. You guys gave a presentation earlier on our stage. So this is NASA HEDO, which stands for?
Human Exploration and Development Operations.
Amazing. So we have some cool stuff here. I mean, I'll let them talk, but this is like habitation on the moon type stuff, right? We are talking about inflatable habitats. We're talking about food stuff. I'm just going to hand this to you guys.
It looks delicious.
We're live streaming right now. I should have prefaced with that. We just like to highlight all the NASA divisions, so you're live right now. But I'm going to hand this over to you and tell us everything.
Okay. All right, I'm Zach Bryant at the Marshall Space Flight Center. So we brought a whole bunch of stuff to show. So we develop and build new habitats for the moon and eventually when we go to Mars. And we have all sorts of stuff here. We have the way that we recycle urine, astronaut urine, and turn it into nice, clean drinking water. That happens on the space station. We're developing new processes for when we go to the moon and Mars.
Time out.
Yes.
Is that water and food coloring, or is that
is
like
100% real human urine? Yes.
Welcome to Kids Week.
Only the best. Yes, only the most accurate. All for science.
I had to ask.
Yes.
All right. Carry on.
The other question is, will you drink the water?
Like right now?
Would you drink the clean drinking water? Would you drink it?
I would trust y'all because the people on the space station live with this stuff. That's so if you had that machine here and you asked me for a sample that I would turn around and drink, I'd probably drink it, honestly.
How long has it been laminated on that display?
It's been there a while.
I don't want that water.
I don't want that water.
Like, I want some fresh water.
It's been there a while. I'll pass off to Larry, let him explain some other stuff.
Yeah, and so on this side of the table, we have one of our internal garments for our current EVA suits. So this is the gloves that an astronaut would wear on the inside that kind of form fits to their hand. And then there'd be a pressure garment that goes over this, which protects them from the atmosphere. Then additionally, we have some of the astronaut food over here. So only the finest we brought today. We brought some cornbread, we brought some sausage, we brought some macaroni and cheese, and we brought some rice pilaf. And so they pull all the water out of it when they launch it so that it's lighter. And so that we save, how much mass we send to space for other things, and maybe use some of the recycled water to refill those. You could also see some of their drinks here. And then we also have some of the shuttle tiles. So, this one would have been on the underside of the shuttle wing. So this is a reinforced carbon material, this black one here, that when it comes blunt body reentry through the atmosphere, when it was taking the crew back, it would see thousands of degrees Fahrenheit. And this would be more of like what you'd see on the top of the space shuttle, which still sees elevated heat when it comes in, but not as much as you would see on the underside of the wing. And then a bunch of swag. Yeah, here, you can talk about the inflatable.
All right, I also forgot. So one big thing we're doing with our moon and Mars habitats is using inflatable structures. So here you see a stack up of all the layers it would take to have a big inflatable, basically a big balloon that the astronauts will live in, from the interior to the bladders that hold all the air in, the strong material that keeps it from popping and expanding, and then all this material that is thermal protection and micrometeorite protection. So this all goes in to our habitats for the moon and Mars.
Which way is out?
Out is up here on top.
Would
be space. down here would be inside where the crew is.
Gotcha. So you have a bunch of expandable material on the outside, and then you get down to the pressure
So it would
vessel.
it would launch basically constricted, and then deflated, and then we'd inflate it. We'd add the air in space, and it expands to this full size.
No kidding. There's some of this similar idea on the space station right now. It used to be the Bigelow expandable activity module. The
100%, the beam.
It's still there.
It's still there, and it's doing fantastic. It's been up there for 6 years. 6 years, maybe more. It's been doing fantastic. So we know this technology works, and it's proven, and it's definitely the future.
Yeah.
It's light and equally as strong if you do it right.
And so everybody knows why that's important, right? Like a lot of times on rockets, we're not just mass constrained, like how much can we move, but volume constrained, like how big is the fairing or payload bay or whatever.
Yes.
And so if you have something that packs into the rocket and it's this big, and then you get it to the moon or Mars or wherever, and then it's this big, you can deliver a lot more volume with less volume when you take off.
Which is important when you're going out as far as you're going to Mars.
Yep. No kidding.
Yeah.
All right.
So I have a question.
More stuff.
I have a question.
What's going on here?
Yeah, she's playing. She's got the glove on. So for those of you that are watching, we have cornbread dressing. We have rice. We have mac and cheese. And we have a sausage patty. And then we have a pineapple drink, an orange mango drink, and a tropical punch drink. So I would like to know in the comments what your meal would be if you had to pick two and a drink. What would you have?
All right. I will read in chat, like right here. Tell me in chat what you would choose from the menu. The options were macaroni and cheese, rice pilaf, a sausage patty for very thin values of sausage patty, cornbread dressing, and you got pineapple, orange mango, and tropical punch.
Or clean water.
Or clean water.
Or clean water.
Previously urine. What would you choose, Alicia?
What would I choose?
Yeah.
I'd probably choose the orange mango drink, and then you said I get to pick two of these?
You get two food items.
Probably mac and cheese and sausage. We do like a protein and like a
So we're gonna have the same meal. Alicia and I are gonna have the same meal.
Nice. I think I would go with the tropical punch. Sounds good, like a high C sort of thing. Man, I don't know, the cornbread dressing or the mac and cheese. I want some like experience, because I'm sure some of these like reconstitute. Yeah, like better. And it might be like, oh, the mac and cheese doesn't do as well as the
cornbread dressing.
It's a gamble. It's a gamble. You don't get to know. I think I'd try the sausage patty just to see.
But there's a whole lab of people that like create this food and test it out. Remember we talked to them on Ask Them.
They try it on the ground too. Like the astronauts going to the station, try a bunch of this stuff, and then they have like, here are the things I prefer.
What a cool job though, right?
Right. Yes.
I just think that'd be so fun to taste test all
Absolutely.
that. You know.
I'm gonna read some chat.
Okay.
What are we saying?
All the food. Nope, you only get to choose two. You have to make your food last. We're not telling you to eat like half a potato or anything. Come on. Mac and cheese in pure water, rice pilaf and sausage, mac and cheese, sausage, orange mango. Okay, sausage, rice, and water.
A lot of sausage.
A lot of people going for
It's
the
the
mac
protein.
and cheese here.
It's the protein in the sausage.
Mac and cheese sausage patty, mac and cheese tropical punch, sausage mac and cheese, no fiber. Oh, where are the vegetables? Someone asked.
Microgreens, right? That's what they're growing.
They're growing it.
Yeah, you don't have to do this to it.
You don't have to reconstitute it. They can grow it in orbit.
No kidding. So another thing, do I have to drink this? It's missing something.
Is this powder?
The water.
We have to put some urine in here, don't we?
Yeah, you gotta add the urine.
Previously urine.
Yes, it is a powder mix.
It is. So
They'd inject it.
So this is just shipped as powder. It's not like a juice box or anything, and you take the water from your purification system.
That's right.
The WRRS. That's not a very cool acronym.
Yeah, or we call it the UPA.
The UPA, urine processors.
The UPA and the WPA. Okay.
Yes.
So you get your water from that, and then you add it with all of these things, and that's how you get your food.
Correct. Give me a microphone.
Oh, have a
So I have a question about this process here, because we kind of skipped over this. So what happens to everything that is distilled out of it to create clean water? What do you do with all of the byproduct?
Yes, so we do have dissolved solids like salts and things in the urine. So that comes out as brine, and the brine is just put in a tank and trashed. They don't do anything with
When you
it.
say trash, do they mean you just shoot it out into space,
They
or you...
they return it on the vehicles,
Got
like
it.
your Soyuz capsules, your Progress, your SpaceX.
They store it.
They store it and bring it home.
Okay.
There is a new process being developed and being used on the space station called the brine processor, where they're able to get some of this extra moisture and liquid out of it as well. So we are further able to make the process more efficient. And then also we mix it with the condensate. So condensate would be things like sweat that comes into the air. We capture it with a
You're
heat
really selling
exchanger.
this. You're really selling
We capture it with a heat exchanger.
Delicious.
So it's sweat and urine. Then
Great.
we filter it out
Yummy.
and have nice clean water.
It's not just the urine; it's sweat and urine.
Yes.
Like,
Yes. NASA.gov to sign up to be an astronaut. So, yes.
It is fascinating, though. I feel like that this is the stuff of science fiction, quite literally, and you're
Yes.
making it a reality. So
Every
that's
day.
incredible.
I have a question from chat here. Oh, I have a question from Alicia stole my microphone. Are these real shuttle tiles or are these like example shuttle tiles?
Those are 100% authentic. I don't know if they ever flew or not.
Right.
But they are real. You can see they have their numbers on them.
Yep.
That's their serial number and where they would go on the shuttle.
It was like VO70 da 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 da, and they were all like for a specific spot.
Everyone is unique
Yeah,
to a
they're
very
special
specific
size.
spot.
Yeah, yeah.
Yes.
You can kind of see there's like an angle to it even.
Oh, it's a special tile.
Yes.
You're right. I didn't even notice that it's not just a rectangle or whatever.
And they're very lightweight.
Mm-hmm.
They weigh almost, nothing.
They're
like
mostly air.
Yeah, it's
Like
mainly air.
Silica
Correct.
fibers and air with a black coating on the outside.
Mhm.
No kidding. I'm going to scroll through chat. People think I'm like being rude, but I'm actually trying to read
Yeah,
chat
you're not just
questions.
looking at your
Yeah, I'm like, this is really exciting.
He's
Let me
got the angle. He can
let me
tell.
check social media real quick. Let's see if there's any questions here. I'm not reading that one. Still preferable to insert name of beer here. Let's see here. Space is awesome. I agree. Don't they need fiber in their diet? So are there other things that you add, like vitamin-wise, that aren't carried in the food? That's a good question.
Supplements.
Yeah, so the main goal is to have the food be your primary means of nutrition. But
Right.
if they need extra supplements, then they do carry those as well.
Carry
along.
vitamins, pills, or something like
Yes,
that they
and,
might
and
take.
each astronaut's diet is customized before they fly.
Right.
So that they'll go and they'll sit with our nutrition specialist and decide from a list of everything they want to eat over their time in space to make sure they have a balanced diet.
Makes sense. And again, it's not like you're just chewing this to make yourself full. The goal is to actually get nutrients and useful things out of the food, not
That's
just
right.
pretend that you're eating. Right?
Now, the astronauts' favorite thing is ice cream.
Yeah.
And they do fly up ice cream on their resupply missions. So that's always a big thing is when they open up the freezer and they get that ice cream. That's always a nice treat as well. So it's not just the.
But
regular
how
ones.
does it compare to the stuff you buy in the gift shop?
I do not know.
Not real, though, right?
I do
That's
not
not
know.
real.
At least
though,
I can tell
right?
this story. Like,
Yeah. Well, no, astronaut ice cream, right? That's the big thing. Everyone's like, "Oh, astronaut ice cream."
Yeah.
Now, okay, yeah, I'm trying to remember. The story of that one was that it was apparently like on the menu for one of the Apollo ones, but they said it didn't actually make it up. Someone who was on that mission said like
Yeah.
that wasn't really something that
sounds
happened.
right. I'm not certain.
But that freeze-dried stuff that they sell in the gift shops,
Yeah.
that's not.
It's
the actual
Yeah.
astronauts
You should
emitter
still
ice cream.
totally buy
Yes,
it from our
yeah.
gift shop.
The
but
astronauts, I mean, you
they
know,
like the real stuff.
Yeah, they do. They like the
Even
real
like
stuff.
large Lucky Charms marshmallow
I
when
know.
you eat that astronaut.
I'm not
ice
gonna
cream.
lie, I actually kind of love that stuff.
like it
though.
too.
Right?
You could just buy the marshmallows.
Yeah. Well,
Yes.
that is basically marshmallows, isn't it? Yeah. No, but that's like a nostalgic thing for us, you know.
Yep.
You go to Kennedy Spacer and you gotta buy
that.
the fake stuff,
Yeah.
right?
Is there anything about space that makes the food taste differently? Like the microgravity or the environment, the atmosphere on the space station?
Oh, yes.
And do you have to do anything with the
Yes,
food so that it
fantastic question.
smells like food?
Yes, so several things happen.
That's a good question.
Your taste buds change in size and shape, so it makes food taste a little weird. And then also you have the fluid shift in microgravity. So the fluid shift comes up, all the fluids in your body, they basically collect in your head. So your head gets puffy, your sinuses get congested, so things don't taste and smell the same. So astronauts love Tabasco sauce, hot sauce.
Strong
Yes,
flavors.
they put it on everything to spice it up and enhance the flavor.
Ah, no kidding.
Yes.
And that's, I mean, on Earth, our bodies are designed to force everything up to our head. Correct. Against gravity. Like
Yes.
I'm standing here and gravity's pulling me down, and my heart has to pump everything up here to get to my brain, right?
Yes.
And in space, in microgravity, it's still trying to pump like that, but there's no gravity to pull everything down that it has.
That's correct, yeah.
I'd never thought of that.
Yeah.
All right, stop the stream. I learned something. We're good.
Great.
Let me see if there's any more questions here. Yeah, I got the question. I saw that was a good question because somebody said, that's a good question. Tag NASA spaceflight. Screaming for ice cream. Can anyone
They're
hear
growing chili peppers up there too for that reason, right? Up in space right now?
I do know grown chili peppers. I
Yeah.
don't know if it's for that exact reason.
The
but it's definitely,
capsaicin, no,
yes,
the spicy stuff.
definitely
Sorry, I
helpful
interrupted
for
you.
sure.
No, it's fine.
Yeah.
I tried the little hydroponic in the kitchen chili peppers, and when I brought them out, they just tasted like water. And I'm like, this doesn't taste like chili peppers. And apparently, there's a whole bunch of stuff you have to do to chili peppers to make them chili pepper spicy.
interesting. Okay. I didn't know that.
Because if they
Like,
just
yeah,
grow, you like bite them and you're like,
hydroponic stuff is harder.
that's water that I'm eating. It's not a jalapeno. It's the weirdest thing.
And strawberries. It took them a while to figure out how to
How to
crack
make
the nut of
strawberry
strawberries
taste.
out there too.
Yeah.
Interesting.
Yeah, anyways.
Awesome.
The question was, can anybody hear you scream for ice cream in space?
As long as you're inside, I think so.
Or you're touching something. We can use vibrations.
Yes, that's true. Yes,
Right?
vibration.
Let's see. I don't see any more. There's just a bunch of people talking about screaming in space now. Car drives. Pepper should be tested. Okay. I think we've gone through a lot of the questions.
Okay. Wonderful.
Nice. Anything else? Did we miss anything really cool at your table?
I don't think so. I think we got it all. Yeah.
It's all really cool. Nice. Can I pick up this shuttle tile?
Yeah, go right ahead.
It is. It's like
Yeah, it's
shaped
cut.
funny. Even the edges
It's
are like
very particular.
yeah, and it's light. It's like styrofoam feels like super low density. I guess is the right way to say it.
I saw one of the heat shield titles for the Orion capsule, and it was kind of similar like that. Where it's very light. It was very particularly cut and like.
Yeah, probably the only other thing maybe to add is, the bigger context of all this is NASA's kind of return to the moon with the Artemis program.
Yeah.
And so that's what a lot of us are working on. And so we kind of have the TV backdrop. We've been showing videos from the Artemis 1 launch in November 2022.
I was there.
The development of our new spacesuits, the development of the Gateway program, some of the human landing system tests that we've done. So that's kind of the bigger framework. So hopefully people are following along with that and are going to, try and follow Artemis 2 next year, catch that launch, and then
Nice.
2 years after, or the year after that would be Artemis 3 in 2026. So
Nice. Good deal. Chat asks if you have a lab I can visit to come and drink some urine live.
It's a Marshall, right?
That's the thing. Somebody get me in touch with the PAO.
You got to come to Alabama for that.
So we do. I'll give you the tidbit.
I asked.
So we do. This hardware was designed and created at Marshall Space Flight Center in
Right.
Huntsville, Alabama.
Have you tried it?
I have not had the chance.
Do you
yet.
wanna try it?
I would. I would jump at it in an instant. So the we do test the equipment with actual engineer urine.
Yeah, actual engineer urine?
From Marshall.
From Marshall.
From employees.
In
my God.
in the toilet, you can make your deposit if you want, and then a few days later, it shows up and they're running it through the machines.
Really?
Yep, 100%. So it is.
No
But I don't think anybody
Only the
can
best.
just get on. Like, you have to, sign up. Right?
True. Yeah. This isn't for the
It's like
general
a
public.
competition
These are
to be a person.
for these are for those who work out at Marshall.
It's a highly sought
Don't
after.
they need to track your diet too though? Like oh you're not drinking enough water for this, or like oh you're eating too much salt. Or
your
something.
diet definitely does affect the chemical
Yeah.
process.
In this or this, right?
Yeah.
Well, we noticed that there was a lot of alcohols in the diet can cause solids to form and clog up the system.
Oh, sure.
So we had to remove some of those from the diet. So the astronaut food again is
the same sort of thing.
Is
yeah.
designed to play nice with all the systems.
No kidding. And the other comment was, if you're not inside, you're probably not screaming for ice cream.
That's right.
Oh, let's see here. Y'all, I think we are going to move on.
All right.
Thank you so much for talking through
Yes.
all your cool stuff.
Thank
I
you
like
all for
your
joining us.
sticker on your you got the embroidered shirt. And he's got the
And I have my Snoopy.
Going
got
for
your
the gloss
Snoopy.
look myself.
the gloss look.
Yes.
Nice. Somebody asked if you were ever in a band.
Yes.
Just yes was the answer. Anyways, thank y'all so much for the time. We will let some other people talk to you here and see you later.
All right, thank you so much.
Thanks a lot. Now I have two microphones and I can talk in stereo. I don't know if it works that way. I'll use the shuttle as my backdrop here. Here's a microphone for you, Lisa. I think we're coming up on the end because it's 4:52 now. So,
I was actually going to say if we have time for like one more thing. Do we want to talk maybe about the eclipse a little bit?
let's go talk
All
about
right,
the
let's
eclipse.
do
We're
it.
talking about the eclipse. She's
Hi,
found
Kat.
another participant
One of
in
my
our
favorite
study.
friends over here. So we you might remember this last year. We kind of bum rushed you at the table here. This is my good friend Kat from the Amateur Astronomers Association.
Hello.
And so the big kind of thing we're plugging right now is the eclipse, of course.
Of course.
And I was wondering if you could give our home viewers across the interwebs a little bit of an update on what's going on with the big eclipse that's coming up on April 8th.
So April 8th, if you haven't heard or if you've been living under a rock, there is a total solar eclipse coming to your town, or at the very least a partial solar eclipse. Every state within the lower 48 will experience this eclipse, weather permitting, of course. And if you happen to live in any of these magical states within the path of totality, you'll experience darkness for about 4 minutes at a time. And if you're outside of the path of totality, you'll have a partial eclipse. And if the weather, of course, cooperates, because it is early April, you'll be able to see this really nice chunk of the sun taken out just by the moon. It'll be really, really exciting.
And so where are you going to be during the eclipse?
I will be in Kerrville, Texas with the NASA team supporting the NASA broadcast on YouTube.
How cool is that? And you have a new job, you were just telling me.
I do. So I am with the Astronomical Society of the Pacific, and I am supporting NASA's Night Sky Network. Night Sky Network is a collective of 450 astronomy clubs across the country that do exactly what the Intrepid does here: bring science to the community, bring science to the public, and educate everyone on astronomy.
Which is awesome. I'm going to be up in Rochester, which is also going to be along the line of totality.
Yes.
And I know NSF
Yes.
is going to be
doing a thing.
I don't know.
Doing a thing.
That's what I'm told. So maybe I'll see you on April 8th from
All
Rochester too. But no, that's very cool. That's very cool that we're highlighting that, obviously.
Yeah.
And everyone at home who's along the path should be checking it out. And even if you're not really along the path, then you're getting some sort of it.
Yep, you're getting a partial at the very least. The only thing I can recommend, please get your solar glasses from a reputable vendor.
Yeah.
If you go to eclipse.aas.org, they have an entire list of resources where you can find your glasses, or you can make a pinhole projector if you don't want to buy glasses and you have the materials at home.
Can you tell people briefly how to do that? Because that is a very simple thing to do, right?
Yes. So all you need is a box, preferably a cereal box, a white strip of paper that you can cut out, something like copy paper, a piece of aluminum foil, and some tape and some scissors. So you're just going to open up the bottom of the box. You're going to tape that piece of white paper to the bottom of the box so that you have a nice bright projection surface. Then close that lid. You're going to cut off a little square in the corner. You'll tape your aluminum foil over that open square, and then you're just going to use a push pin or a needle to poke a hole through. On the opposite end, you're going to go ahead and cut out another square where you're going to put your eye, and this way you'll look through. The sun will be behind you, and you'll be able to project the sun down to the bottom of the box, and then you can actually watch this eclipse happen in real time. Another thing you can do if you're at home, you can use a spaghetti strainer or a colander, or you can also do kind of like this cross grid with your fingers so that you can watch the shadows appear on the floor. Or if the leaves are on the trees, you can use that. You can also use mirrors from like a disco ball, which is something that we did in Ely, Nevada for the annular eclipse. That was kind of fun. You can get really creative with it.
Everyone's got a disco ball at home, right?
Exactly.
And yes, if you are local to the New York City area or want to be, we won't be in totality. We'll be at about, 82, 80?
It's about 90%. It's 89.9 something.
Okay, about 90%. We'll be doing things here at the Intrepid as well. We're going to have education demos up on the flight deck. We actually will be giving out glasses if you come by. We have special Intrepid branded Eclipse glasses that are safe, you know. So yeah, if you want to get a free pair of glasses, you can come here too.
I found the picture, like the last annual eclipse.
There you go.
Did it with my hands. I was out hiking and I didn't have eclipse glasses, and I did the exact same thing you just showed.
There you go.
To see the sun going in front of it. I was like scrolling through my phone, like, I took a picture of that. The tree leaves too.
Yes, tree
like
leaves.
The tree leaves.
The colander.
Super cool. There are so many different tools. You can use a spoon that is slotted as well. There are a lot of things that you can use for this eclipse.
Awesome. Thank you. All right. Any?
I'm like.
I know he's.
I just got distracted and scrolled through to find that picture on my phone. I was supposed to be getting questions from chat. Let's see here.
Any other cool astronomical things to be looking out for coming up?
There might be a comet during the eclipse.
During the eclipse?
Yes. So during totality, if you're in the path of totality, you're not going to see this if you're in that partial state. But if you are in totality, there is supposed to be an eclipse, or a comet rather, that will be kind of just off to the side of the sun, in addition to planets that you would typically see at night. Just now that the sun is obscure, you'll be able to see them during the day. Don't quote me on the comet, though, because comets tend to break up as they get closer to the sun. So we might, it might not happen, but there's a possibility that we will have a little comet.
Question: what was the website you said to make sure you got good glasses?
Yes, it is eclipse.aas.org.
Eclipse.aas.org.
Yes.
If one of the moderators could type that out and make sure the link goes to the right place, it's eclipse.aas.org.
Yes, that is the
Nice.
American Astronomical Society. They have an entire list of things for the eclipse: where to buy solar-safe glasses, where to buy solar filters for binoculars or telescopes or camera equipment. If you wanted to make pinhole projectors or other items that you could use at home. If you wanted to link up with different organizations like an astronomy club, or if you wanted to link up with NASA Solar System ambassadors, it's a whole treasure trove of eclipse knowledge right there on the website.
Nice.
You just nudged me. I'm a Solar System ambassador, as is Kat. Shout out to the Solar System Ambassador Club. We're nerds.
Nice.
We're nerds. It's bad.
Let's see here. Some people are saying what their plans are to drive or where they're going to go to try to see the eclipse. The name of the comet. No guarantees on the comet, but do we know what the name of the comet is?
Let's see. I got to pull this up on my phone.
We can bring it up on the phone real quick. That was just a question that came through. Give us a second, Ship 26. What do y'all think of this, by the way? Y'all I know we're running around, we're crazy. Lisa and I just like talking to people that have cool stuff. What do y'all think of the stream here? Was this worthwhile spending our time today, or y'all like?
Of course it was.
It's not Starship. I don't want to watch it.
Let's see. So this comet is Comet 12P/Pons-Brooks.
Why don't they just call it like Bob?
They are also calling it the Devil Comet. That's
What?
yes.
What? Wait a minute. This just took a turn.
I
Why?
know. So this is from Astronomy
The Devil
Magazine.
Comet will be visible during the 2024. Okay, well, why is it called that though?
That is a really
why?
good question.
I need to know.
We consult the oracle.
Someone figure it out and put it in chat for us. Oh my gosh.
So yes, so it is possible that we will have this comet during the solar eclipse. But of course, as I said, comets are balls of ice, and as we approach the sun, what happens to ice? They melt. So
the
we'll
sun
see.
is like a big anti-ball of ice thing.
Exactly. So we'll see. We'll see how it shakes out.
Nice. Well, thank you so much for the time.
Thank you. Absolutely. Thanks for stopping by.
We'll hop over here so some more people can talk to you.
Yep.
I will take that. Thank you.
Thank
All right.
you.
We got one more, I think.
Okay, sure.
Do we
yeah.
have one more?
Yeah.
We have one more,
Let's
y'all.
go on over here.
We're not done yet. Now, the museum's about to close. It's 5 o'clock.
Yeah, we're shutting
everybody's
this place
filtering
down, but we
out.
got one more
It's
step.
time for Kids Week to close for today, but it goes an entire week, right? It's not just today. It's going to be going on all week. There's the beeps indicating that the museum is closing. But we work here. At least it works here. Stand by during the announcement. We're just saying the museum is closed. We're going to make sure they don't have to run at exactly 5 o'clock to catch a train or something. So give us just a second. I like it. I do like doing this. I know that we're all over the place, but we really do have a lot of fun. If you asked us, maybe he'll do a couple more interviews. I mean, we're seeing what we can do here. We good to go?
Yeah. All right. Yes, let's do it. Okay. I know. Thank you for staying too, because I know everyone's wrapping up now. But this is the Space Telescope Science Institute. I got that right.
Nice.
And I'm going to give this to you. You can just introduce yourself and tell us a bit about what this is all about.
Okay, so my name is Marta Irene Saladino. I am an education and outreach scientist at the Space Telescope Science Institute. And what we are bringing here today is all the science of the Hubble Space Telescope, the James Webb Space Telescope, and also we're introducing the NASA Grace Roman Space Telescope, an upcoming mission from NASA that will launch within the next few years. We're very excited to be here. We have activities about stellar evolution. We have activities about how the universe is expanding. And we also have web VR so that people can explore all the amazing science that the James Webb Space Telescope is giving us.
Nice. What type of jobs do y'all do? Like, do you stare through a telescope all day? Do you do math? Like, what do y'all each do? Could you tell us?
So I am a scientist, an outreach scientist, and that means that I bring science to the public.
Nice.
So I make sure that all the science that astronomers are doing and all the amazing discoveries from the telescopes can reach the general public. Jessie here is an educator, and you can tell them what you do.
Yes. So, hi, I'm Giuseppe Perez. I'm a education specialist at Space Telescope Science Institute. So I actually don't have a science background, and I like to make this very apparent up front because a lot of kids think you need to have a PhD to work in space, and you don't. You can have a pathway where you're a really good writer, science writers, we need those. You like to draw and animate, we need graphic designers to visualize the universe. And if you like to educate and reach different populations on the ground hands-on, you can be educators in the field building hands-on activities, program guides, and funding museums and libraries to utilize these space resources to inspire a new generation of stargazers. So you don't need the PhD, but if you do want it, that's great. But you can also be a part of our program as well.
Nice. I can tell y'all talk to people a lot because you're like waving your hands around. Like they talk with their hands, and I talk with my I talk with my hands a lot. And both of y'all are like waving your hands around.
Yeah.
No, don't apologize. Like I do the same thing. Sometimes I throw my phone at people because I'm like waving my hand around so much. It happens.
It does happen.
Nice.
So something I just want to point out real fast, because I think this is great, and we actually try to incorporate this at the museum. Can you talk to us about these things?
Absolutely.
And it says, as you can
It says, please touch.
Yeah, so these are our tactile panels of different images. So this is a web image on the left here of Stephan's quintet. So these are 4 galaxies that were imaged. They were part of the first images from Webb Space Telescope. So this came out through first images July of 2021. And we are able to view and raise this image by working with the National Federation of the Blind and low vision experts to create resources for students that can't visualize the universe with their eyes or in normal ways. But it is universal to all audiences because everyone loves to touch things. So those are galaxies, and then this is a raised Eagle Nebula from the Hubble Space Telescope. It's that famous image that we've all known that sort of opened up our pathway to understanding the universe and visualizing it for the first time. So we decided to raise this famous image as well as the galaxy, and if you read through it, you're able to, by touch, you should be able to read through it as someone with low vision or no vision. So it is telling you different things based off of the shape, the height, and how it is expanded on the paper, as well as the texturalization as well. Oh, sorry.
Like this.
Oh, yeah.
If we get like that, the camera can sort of show you how that's raised up.
Yes, exactly.
So it's not just a flat thing, it's
it's
raised up.
It's a raised surface, and this is great, and we provide this as a resource for informal learning sites who are trying to reach new audiences in different ways, and kids love the tactile panels. It's a huge entry into asking questions.
Yeah.
And once they start asking questions, you have their attention, and then you can finish up the program with their attention still there because they're able to explore it on their own.
Plus, you go to the museum and most of the stuff says "Don't touch."
Exactly.
Right, and
yeah.
you have a sign that says "Please touch."
Yeah.
Like, you'll saw the sign, right?
Yeah. So it's even more inviting as well, which is also another perfect thing because they're like, finally, we have something in our institutions that kids can engage with. So this is something we've been doing recently for about 2 to 3 years, and it's been very successful. So we are going to keep doing it hopefully in the future. But yeah, just another entry point into a new audience.
How do you make them?
So we work with a partner. So we partnered alongside the National Federation of Blind. We also work with experts who do this work. It's called 3D PhotoWorks.
Right.
So they are experts in 3D capability and product production. So they're able to use the 3D mechanics to raise the image,
Yeah.
and then they sort of pressurize it with foam, and it's a really cool. I'm not sure how it operates because
Gotcha.
they are the experts. So please partner with experts when you're doing stuff like this. But the partnership allowed us to create these things, and it takes time as well because you want experts who are blind as well to work alongside you to make sure that the work you're doing is accurate and can be inspiring to them.
That's fantastic. It's just so cool. Like, think about it. You have to decide what needs to be raised up and how the contours work.
Yes.
Y'all gather the imagery.
Yeah.
You get the data, I guess.
We get the data and we get the imagery, and then they tell us how it all works.
How that can
it all can be.
presented
And-
like this.
Yeah, and so we did a lot of testing, and I know this because I worked alongside my colleague that led this, Tim Rue, at Space Telescope, but we did a lot of experimenting and prototyping.
Yeah.
So showing prototypes to our blind experts and saying, can you capture what we're trying to convey? And a lot of the time it was a lot of no's until it was right. You know, you're just working through the mistakes because we aren't blind. So
Yeah.
how can we make something if we don't know? And it's working alongside those experts.
Absolutely. That makes good sense.
Yeah.
No kidding.
Yeah, we actually have had a few live streams that we did talking about accessibility, particularly in relation to astronomy. And the last one we had was about
Sonification.
sonification of data,
Yep.
which was fascinating.
Yeah, so we do sonification as well. We don't have any examples here today, but we do sonify our images.
Nice.
So that is another way we access point to this audience too.
Very cool.
Yeah.
Well, we have kept y'all after class now
That's
by
okay.
10
Yeah, they're
minutes.
taking everyone out here.
the security is like ushering everybody out. So thank y'all so much
Thank you
for talking with
for the
us.
time. We appreciate it.
Absolutely.
All right. And thanks for coming to the museum too and doing this with the kids.
Absolutely. Thank you.
All right. We're going to mosey this way over, I guess, to the Kids Week, man.
Yeah, let's go back to Kids Week Banner.
And yeah.
Thank you if you're still watching us.
We just walk away when we're done, by the way. We're just like, okay, thanks, bye. We're still live. But folks, thank y'all so much. We're going to get over here and talk real quick. Where is my other window? There's my other window. All right. We got like a Kids Week banner. Yeah, there's a Kids Week banner behind us. We have a ton of fun doing this. I don't know if it comes across. I hope it does.
I'm
Like,
having a great time.
even if I'm not good at like photo booths or whatever, like I have a blast.
How do you be bad at photo? You just hold.
The outro.
Yeah.
She is typing. Stop and start the pack remotely. All right,
Okay.
let him stop and start the pack remotely. We can sit down.
Just hang out.
Oh,
Still talking?
we're stopping and starting the back remotely. Hang on a second.
What does that mean? Back.
Are we back?
Hey, we're back.
We're back.
Hi.
It's harder to get the Kids Week banner, but we sit down. But we've been
That's
walking
okay.
around a lot.
That's okay.
We're live now. Okay, cool.
Amazing.
So anyways, I hope we have y'all get the point that we have fun doing this. It's not like there's many people popular watching these sorts of streams, but they're so important to let people know what the museum's doing.
And there was definitely a recurring theme that I noticed this year about you don't have to be a scientist or an engineer in order to do this sort of cool stuff.
Yep. That's exactly
A
right.
lot of people
So
were saying that, yeah.
the folks that are showing up and supporting this, like you can support the museum. There's lots of different ways to do it. IntrepidMuseum.org has a lot of ways that you can get involved or sponsor, donate to the museum, that sort of stuff. But y'all have been actually supporting the museum today during the stream.
Thank you so much.
I couldn't read them. Like I wasn't really set up to read those in real time on my phone. YouTube doesn't really make it easy. But I did want to say thanks real quick to some folks. I'm going to be looking at my phone. Joseph DiGiorgio. Thank you for donating to the museum. One came through as anonymous. We got Joe McCarter there as well. We've got Airbertak. Airbertak did $100.
Amazing. Thank you so much, really.
Normally, like if you do a super chat, it's not a donation because NSF is not a nonprofit. But when we do these donations with the museum, that is going to Intrepid Museum.
It is,
Which
yeah.
is a 501c3 nonprofit,
We are.
right?
Yes.
They are, like
Yes,
officially.
we are.
So we got Methane Man, one way or the other, did $50 in there. Another anonymous one came in. You could do that as well. I think there's like a checkbox or something. You can either do it anonymously.
We love you either way.
Either way, yeah. Mark Garrett's did €50 in there as well. Bideford did $50. Phyla Kid, I'm going to go with Phyla. There was a
Stephen Hansen, we missed him.
Oh, we missed Stephen
There we
Hansen
go.
up there as
Okay.
well. Yep. All of the different people.
Yeah.
We do those usually with the museum streams. Yes. And when you do that fundraiser sort of support, you're supporting the museum directly. Yes. Like that doesn't even pass through NSF. We're not trying to be like, oh, we've raised this much for there now. It just goes to the museum so they can keep doing cool stuff like this for kids and families and sharing it with all the interactive stuff. Tomorrow, when we have the astronaut talk, we'll have ASL.
We will.
Tomorrow.
Yes, accessibility is really important
It
to
really
us.
is.
In fact, we've got our accessibility
We're
director
doing
right over
an
here.
accessibility plug
Yeah.
right now.
Yeah, she's literally putting down the seats for reserving for ASL seating right now. No, we had a hearing loop out here the whole time during the stage presentations.
You have like special tours of the museum.
We do.
where
We
you
have
can
touch
sign up
tours.
and there's like what's the right terminology? Help me out.
Low
like when it's quieter
visual.
at the museum.
Sensory friendly.
Sensory-friendly stuff. And not everybody wants to fight through the crowds and that sort of thing. Like that doesn't work for a lot of people. And so the museum does so many different accessibility things so that everyone can enjoy what the museum does and all the different ways that they enjoy things.
Right,
That they can experience things. So I think that's our
thank
outro.
you. Thank you all so much for your donations. Really, it means a lot. We don't do this to try to beg for donations or anything
No.
either. We just want to bring cool content to you, but it really does go a long way to have that. So thank you so much.
Over $1,000
That's
today.
amazing. Oh my gosh. Thank you.
Who even knew?
Thank you. You guys are the best.
Anyways, we are going to be back tomorrow.
We are.
Tomorrow at 3 o'clock.
We'll be a little more professional tomorrow.
Don't overpromise. We have an astronaut talk happening tomorrow.
3 o'clock.
Joan Higginbotham.
Joan Higginbotham.
Thank you.
And Mike Massimino, of course. And I didn't realize this. They are in the same astronaut class. We're in the same astronaut class.
All right.
So they're going to be telling funny stories about each other, I guess. I don't know. It's going to be great, though. So that's our Astro Live for tomorrow. It will be here again, 3 o'clock.
3 o'clock.
We are going to be streaming it from the stage with ASL.
Yep.
And then afterwards, we will slip her upstairs again and do a little one-on-one like
We'll
last
see if
time.
we have time. I know she had to go real fast.
We
Remember?
can. We're going to
We'll see how we are on time with that.
So we'll be
tomorrow.
able to
I know she's
answer
got a
some
flight to catch.
questions from you all too.
Yeah,
is my
yeah, yeah.
point.
That's the plan.
That's the plan.
But anyways, y'all, I know we're running around. Like I've got YouTube on my phone, and I'm like reading chat. Twitch, I stopped in and I checked in with y'all a couple times as well. We used to do this on Twitch all the time. But wherever you're
Back in the old
watching, you may be on one of the museum channels. Toss the museum a follow. If you're on NASA Spaceflight, you probably already follow us. But go check out Intrepid Museum or
Like
any
and
of the.
follow and subscribe and
Like and follow
ring
and
the bells
subscribe.
and do all the things.
All right, let's stop the stream now. No, this is really cool. We have a lot of fun doing it. So thank you all for hanging out with us and making this sort of stuff possible. For now, producers, I'm going to telegraph this to you so you can go to the away screen and play the music. But thank y'all so much for hanging out with us today. Hope y'all learned something or at least enjoyed it or whatever. For now, we will see you nerds later.
Bye.
Now.
And here we go. We have liftoff. Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up.
Echo Delta nominal.
Fighting downside FD off. Bring in FD off. Off. It's orange! 145! Oh my god! Decollage. Put that in the big bag,
343 unfolds to go.
Indeed. We rise together, back to the moon and beyond.
This methane would be igniting flare, correct?